Hello everyone, very good afternoon to all. Myself Manish Pandey and my colleague Ariana will be hosting this session. I would like to welcome you to the third and last day of the fourth Young Professional Congress. Today we with the last one double. We start with hydrodynamics as then it once and a half hour we have a flood risk management session, and shortly after in 3 hours we have water resources management that is divided into two sessions. So without taking much time, I would like to introduce our today's chairs for hydroinformatics, that is Professor Gabriel Fanny and David Vincenti. So Professor Gabriel Franti is full professor in urban water systems at the University of Enna, Italy. Since 2018, his main research topics are related to urban water system, water quality, environmental modeling, and related uncertainty. Within IAHR, he is HS Joint Committee of Hydroinformatics and Associate Editor of Journal of Applied Water Engineering and Research. Our second chair, Professor David Vincenti, received his master's in civil engineering from Technical University of Madrid. He currently works for CIMNE, where he is involved in research, technical development, and has collaboration at national and European level. He has worked on multiple research projects, being his fields of expertise, the applications of numerical modeling and machine learning based models to different areas of hydraulics and environmental engineering. So, our chairs, now over to you.
Thank you very much, Manish. Hello, everyone, and please let me introduce for 30 seconds the community, the Joint Committee on Hydroinformatics that is jointly hosted by IAHR and IWA. Only a few words just to stress you two aspects, two appointments that we will have in the very near future. That is the next conference on hydroinformatics that will be held in Beijing in the next year, in May. And the deadline for the abstract submission will be on the 15th of December. So if you are willing to continue your work in the hydroinformatics and discuss with a lively community, please consider the conference that will be held by, will be hosted by HR and IWA together. And second point, we will have elections in the community, and for the first time, we will have components coming from the young professional network. So if you are willing to work together inside the community and helping the community to grow, please consider your possible nomination to the joint committee. Details can be found on the website of the IAHR, obviously. So if, David, do you want to tell something in the introduction?
Thank you, Gabriel. No, I think that you have done a good presentation, so I think we can start with the speakers. Thank you.
Okay, so we can start with the first speaker. The poster title is Development of Riverbank Erosion Warning Systems for Braided River. And the authors are Muhammad Muqtadir Hussain, and should be on online. Yes, okay. And you have the floor, obviously.
Hi, good morning, good evening. Basically, I am the presenting author. I am Shampa. I am the first author. But maybe mistakenly, the second author name was mentioned. Welcome to our presentation on development of riverbank erosion warning system. Here, basically, we worked with the development of erosion system that is covered the river bank and the river island or the river bars. Bangladesh is a very populated, densely populated country, and many people lives in the river bank side and as well as the river island. So, the river bank erosion, as we have alluvial rivers, so there are lots of consequences of bank erosion, and it's a very dangerous hazard basically for our country. So we try to develop a warning system.
I don't hear the audio.
Am I audible now? Hello.
Yes, you are.
Yes.
Yes, you are.
Yes, now we
Yeah.
can listen to you.
So when we are basically working river bank erosion system, the main problem is the bathymetry, as the braided river changes very frequently, and authority, it is Bangladesh Water Development Board, they cannot took the bathymetry that is so frequent and so dense. So what we did, we basically developed based on river bathymetry, and in the previously there are many developed remote sensing based bathymetry that is basically tested for the sea level sea bathymetry, basically using the method or but we applied method and we found that that is not proper for capturing the braided method. So we developed one methodology, and you can find the equations in our abstract if you are interested. What means to the using IAHR and the green band for bathymetry, and you
I think we have some problems. We cannot hear you.
yeah I found many times it's disconnected. Is it from my end problem?
I'm not sure.
Yes, this is from your side, I think.
Hello,
Because
can you
we
can you
hear you.
hear
We
me?
can hear you. Yeah,
Yeah.
we can hear you.
Okay, can you
Again, it is disturbing. I think your network is
should I
not.
continue? Should I continue?
Yes, yes, think you can continue.
Okay. So
Okay, I think it is not hearable. I
Yeah.
would suggest you try to fix
Find that-
the audio issue, and we move to the next speaker, and we leave you a bit of time at the end after everyone has presented to finish presenting the poster or representing totally, okay?
Okay, good. So can we go to the second presentation? That is application of neural network for stratification modeling in shallow lakes. And this will be presented by Sebastian Torok. Sebastian, you have the floor.
Hello, everyone. Can you hear me?
Yes, clear.
Yes, we can hear you. You can start, Sebastian. Hello, Sebastian. Are you speaking?
Okay.
Does anybody can speak, Sebastian? Sorry, or it's me?
Sorry. Can you hear me? Okay, I have internet connection problems. I'm trying to solve them. So I'm just disconnecting every time from the server.
Okay, now we can listen to you very well.
Okay,
You
then.
can start.
Okay, thank you. Hello, everyone. My name is Sebastian Török, and today I will talk about the application of neural networks for stratification modeling in shallow lakes. Our investigation area was Lake Balaton, which is a shallow polymictic lake in Hungary, mid-Europe, which has a big diurnal stratification. This means that through the day, stratification can build up, which then at night it breaks and it starts over again the next day. And how does this look like in practice? That's what the first figure shows us, where we can see different water temperature measurements at different depths along a water column, and with the dashed lines, you can see the potential energy anomaly index, which we used to characterize the strength of the stratification. When the water column is mixed, so we have only one temperature, our anomaly index value is 0. But when we have stratification, its value increases, and the stronger the stratification, the higher our value is. And to model this, we used a simple model system with two submodules. The first submodule was a zero-D endurance model, which uses routine meteorological data to calculate depth average water temperatures and its temporal changes, while the second submodule was an artificial neural network, which uses the results gained from the zero-D model, so the depth average water temperatures and their temporal changes, routine meteorological data, and water depths, and to calculate the earlier mentioned potential energy anomaly index. We trained our model for 3 years, and then we ran it for 40 years, starting 1981 to 2020, and then we compared the results with a physical-based one-dimensional model with a general ocean turbulence model. On the second figure, you can see the schematic drawing of our modeling process. And for the results, we get that the ANN can follow the course of the diurnal cycle of peak stratification with high accuracy. And also, it showed the same long-term change related to the climatic change as the physical-based model. When we compared two models, we got that overall, the ANN gives us a slightly worse approximation to the measurements, but in some cases, it proved to be better. The reason behind this, in the one case, can be because in the physical-based model, we used a constant light efficient coefficient, which is a time-varying parameter, while ANN doesn't use any kind of parameters. So it's possible that the ANN might take the light extinction's temporal variation into account indirectly through wind forcing. As in the case of high wind, the sediment can stir up, affecting the light extinction processes. On the other hand, while our ANN gave us slightly worse approximation, can be because of the water depth was a crucial factor in our training. And even though we used 3 years of data to train our model, this was only a small part compared to the whole scale. So our model had to extrapolate in many cases. And when it comes to extrapolation, ANN are a little weak against it. So the results can become somewhat uncertain. In the third figure, you can see the measured and simulated potential energy anomaly time series. Then you can see how well our ANN performed. And for the conclusions, we get that the ANN model provided to be an efficient tool for estimating the weak stratification of a shallow lake, as it could calculate small time-scale fluctuations with high accuracy, and also it was able to detect the impact of climate change on longer timescales. We also get to know the importance of the training data, as we have to cover a wide range of hydrometeorological conditions for our model to perform better or make our model perform better. But all in all, we got a really fast and simple model which uses only meteorological data to calculate the strength of the stratification, which means our model has a potential in nowcasting. About the results, more details can be found in the abstract. And with this, I would like to thank you for your attention. And if you have questions, feel free to ask.
Thank you very much. We will have the questions in the end. And now we have the third presentation, that is transformer-based surrogate model for real-time forecasting of inundation maps. Matteo Pianforini, you have the floor to describe your poster. Yes.
Yep. Thank you. So good afternoon, everyone. My name is Matteo Pianforini. I'm a PhD student at the University of Parma in Italy. The main goal of the present work is the development of an artificial intelligence-based algorithm for real-time forecasting of flood maps with the aim of reducing the impact of extreme inundations. So the model I developed, named FloodFormer, is a transformer-based surrogate model. It extracts the spatio-temporal information from a sequence of water depth maps and predict a water depth map one frame ahead. So as we can see from figure 1, the model is composed of 3 consecutive blocks. An encoder, which uses a two-dimensional convolutional neural network to extract the spatial information from the maps and reduce their dimensionality. A transformer architecture that analyzes the spatio-temporal information in the map and predict the future maps, and a decoder, a two-dimensional convolutional neural network that reconstruct the predicted maps. So once the model is trained, we can predict only one future frames. Obviously, for the application of this surrogate model for real-time forecasting, we need to predict many future frames, future maps. So for this reason, we implemented an autoregressive procedure that used the predicted maps as input data for the forecasting of the subsequent instant. This methodology allows to predict many future frames using a restricted number of input water depth maps. So as a case study, we consider the hypothetical failure of the Parma River flood detention reservoir dam in Italy. Due to the lack of real inundation maps, we create the samples for the training and testing dataset of the surrogate model using the result of numerical simulations developed through a two-dimensional shallow water equation code named ParFlood. So in figure 2, we can see the results for the autoregressive prediction of the water depth maps in the testing dataset. So we consider a number of past frames, so the number of maps used as input data for the autoregressive prediction equal to 8, and we want to predict a number of future frames equal to 60, which corresponds to 2 hours of real time due to the using of a temporal resolution of the output map equal to 2 minutes. So the first row of the figure 2 corresponds to the ground truth water depth maps obtained through the numerical model, so the ParFlood code. The second row corresponds to the predicted map with the surrogate model, so the FloodFormer. And the last row corresponds to the differences between the predicted and the ground truth water depth maps. So as we can see from the figure, the error outside the river region are lower than 25 centimeters, except for some specific location where the error increase up to 1 meter. So these errors are acceptable for the real-time forecasting of downbreak scenarios on real bathymetries. Indeed, the average root mean square error for all the 60 predicted frame is is about 9 centimeters. Furthermore, we made some experiment reducing the number of past frames, which is the number of maps used as input for the autoregressive prediction. And for example, reducing this number from 8 to 1 or 2, the accuracy of the prediction remains quite good. And indeed, the average root mean square error increases slightly and remains lower than 10 centimeters. The computational time of the autoregressive prediction of these 60 future frames, so 2 hours of real time, takes less than 1 minute using an NVIDIA A100 GPU. So in conclusion, the short computational time and the good accuracy make the FloodFormer model a suitable tool for real-time emergency applications. So thank you for your attention.
Thank you, Matteo. So we can go to the fourth presentation. The title is Hydrocompute an open source web-based computational library for hydrology and environmental sciences. Carlo Eraso Ramirez is the presenter, and you have the floor.
Can you hear me? And can you see my screen?
I can share it for you. Okay.
What do? Do I share my
Stop sharing, please.
share the PDF? Sorry. All right, give me a sec. Well,
Do you see it?
I don't. Yeah, I can see it. Okay. So good morning, everyone. My name is Carlos Eraso. I will be presenting the project we developed at the University of Iowa's Hydroinformatics lab, and it's called Hydrocompute. So I'll give you a little bit of a background. Nowadays, web browsers are key components of our everyday lives, right? And they come packed with very interesting and state-of-the-art features and standards. Some of these standards include multi-threading technology that allows developers to create applications that leverage CPU and even GPU usage. Moreover, we're also able to run different binary pre-compiled code coming from different sources within the web browser. And now to this end, we have developed the Hydrocompute, which is a computationally driven library that runs on the client side and uses client-side resources for fast computations. So I'll take a step back. Client-side, I mean in the web browser, whatever you have installed in your phone, in your local PC. What we're trying to leverage is how much hardware do you have over there, and just using the web browser. No other input output coming in from there, just whatever you have available as a resource. So based on that, and in here what I have on the figure 1 is the architecture we have developed on 4 different interfaces. So the connection layer, it allows data and configuration input and output. So we created this framework for input data on how the input data should look like and how the output data should look like. Everything is explained in the repository. An engine layer that leverages graph theory to create a scheduler using directed acyclic graphs. So that think about when you have a rainfall, a model rainfall on one side to create all the rainfall inputs and calculations, and afterwards that's fed into a model that's another calculation. So we used graph theory to create this very nice scheduler that leverages these ideas. And we run sequential and parallel simulations based on this. A threading layer that spawns threads based on the user inputs. These threads are coming both from the CPU and or the GPU. So for the CPU, we're using this technology called web workers. So web workers allows us to run fast and heavy computing using the CPU resources. And we're using this other standard called web GPU, which is fairly recent. It's actually just released this year in 2023. To create and use whatever we have available as a GPU, either an integrated hardware or a dedicated hardware for that matter. And then afterwards, this threading layer calls into another layer called worker script layer that looks into specified folders for the instructions laid by the users. So something important about the library is that we develop it thinking that the users can bring their own code using the framework that we have developed for different kinds of code. And for this purpose, we created a flexible and let's say user-friendly interface. So how this looks like is what I'm showing in figure number 2. So we have, it's an API, right? So it's mostly for developers. And the idea is that you have 3 different functions: a declaration function for the computing library, compute the data, which allows configuration objects passing as JavaScript arrays, so coming from APIs from different resources, or coming as configuration objects. And compute.run, which the user has to specify how to run a computation based on if either it's sequential or parallel. And we have this all on the GitHub. So afterwards, everything is laid out by the user. The next steps are that both results and configuration objects are given into the library, and the library runs depending on the subset of functions, how they should run. So I wanted to show an example, live example. I don't think I'm going to have time for that, but everything is on the repository, so you can take a look. But in here, what I'm showing in figure 3 is a dashboard. So we created this dashboard to exemplify how this looks like. We also created another library that I presented actually last year in this same Congress, called Hydrolang. So Hydrolang connects with different APIs around the world, right? So in here, what we did was we created a dashboard that connects with streamflow data from USDS across the state of Iowa. So depending on counties, we have many streamflow data, and we run statistics functions based on this. So what statistics functions? We develop an RMA process, Monte Carlo simulations, autocorrelation simulations, and in total 4 different types of simulations that run for each of the stations. And each of the stations were created from the 1900s all the way to 2023. And afterwards, all of this is running on the background. So the user can visualize how this streamflow has been moving based on the preconceived functions for the autocorrelation functions. And for another example is we did this for multiple stations for the quarter of the states. So the quarter of the state, think about around 250 stations. And for 250 stations, the total number of time that it took to run all the functions that we required to run was 1.5 minutes, which I think was pretty fast. And 5.7 in total, which meant data cleaning, sorting, and removing some outliers that were not helpful. So future work, well, it is a standalone library. So the idea is that users can bring in their own code, right? So think about code from C, C++, Fortran, Python. You precompile it into this binary format, and afterwards we use the library to bring that code into and available for a web application. It is a flexible and object-oriented architecture that allows it for a Spawn to create a much larger system. And it is a work in progress. So the standards are very new. So we're still testing and experimenting how this can be leveraged for a better usage. And that's what I have. If you want to see more afterwards, please let me know. Thank you.
Thank you very much, Carlos. We move to the next presentation, that is enhancing hydrological predictions in the Tatali River Basin, a multimodal ensemble approach leveraging machine learning algorithms. And the presenter will be Umut Kirdemir. Please.
Hello, can you hear me?
Yep.
Yeah, I greet all of you. I'd like to talk about machine learning integration into multimodal ensembling for stream flow predictions. As known, there are varying modeling strategies for stream flow predictions, and they're basically black box, gray box, or white box models. And so when generally evaluated, they can produce different results such that it yields in uncertainty or variability in predictions. So in the literature, when the literature is checked, use of multimodal ensembling is recommended. So in this study, I experimented use of machine learning algorithms for multimodal ensembling. The study was conducted in Tatlı Basin, which is located in western part of Turkey. For hydrological modeling, 4 hydrological models were utilized. They are generally lumped, conceptual, and they're in the time scale. The use hydrological models are 5-parameter 25 water balance model, 4-parameter Thames model, 5-parameter dynamic water budget model, and 5-parameter ABCDE models. And all these models were calibrated using flower pollination algorithm, which is a meta-heuristic algorithm which was developed by Yang in 2020. And they used machine learning algorithms for multimodal ensembling, artificial neural nets, support vector machine, random forest, decision trained, XGBoost, and to evaluate the single models and multimodal ensembling models, niche and percent of bias evaluation criteria were used. And when we look at the figures on the left-hand side, we see that niche performance for the single models are really high. Actually, they are about above the 0.8 value. But when we look at the percent of bias value, we see that in the training data, they generally perform well. But for the testing, they are generally perform, we can say, bad, because the results, absolute results, are above 40%. So when the models were ensembled by machine learning algorithms, we see that on the right-hand side, the table, we see the best ensembles, and in terms of performance criteria, and among them for training and for testing, we see that random forest and XGBoost performs really well. And for percent of bias performance criteria, we see that the bias value decreases significantly. So in conclusion, multimodal ensembling must be used, and use of them is recommended in terms of our study here. And also XGBoost is among them. XGBoost can be promising. Yeah, thank you for listening.
Thank you very much. So we move to the next presentation, and the title is Numerical Model of Aquatic Vegetation, a brief analysis of the research scenario from 1980 to 2022. Thais Yamasaki, you have the floor.
Thank you for the introduction. Hi, everyone. So I'm going to present a very brief picture of the trends in the academic publications that use numerical models of aquatic vegetation. As some of you may know, modeling aquatic vegetation numerically has become a useful method to study flow vegetation interactions in basic and applied research. This is a fairly recent topic that is gaining momentum with advances in computational processing and numerical models, and also with an increased interdisciplinarity. So I wanted to briefly analyze its current status by framing the time evolution of publications and the distribution of publications by country of first author and by journal. To do that, I did a systematic data collection in the Scopus database. The search was based on title, keyword, and abstract, and it included articles, reviews, book chapters, and data papers published until the end of 2022 and in English. The search query included numerical modeling of all types of vegetation in different scales and aquatic systems. Unrelated studies to the topic were removed, and references from the remaining studies were analyzed to potentially find additional studies. As a result, the final data comprised 405 studies. The first study was published in 1980, less than 50 years ago, which shows that the topic is relatively new. Looking at figure 1A, the number of publications has been growing over the years, indicating a positive trend in the academic interest towards the topic. In figure 1B, you see the number of open access and free access publications in gray, and the number of paid access publications in black, plotted in 5-year intervals. The proportion of open and free access papers to paid access papers grew from 11% between 2004 to 2009 to 67% between 2016-2022. This growing proportion reflects the academic efforts in providing readily and freely available studies, and indicates that open access publications may eventually become dominant in the future. In figure 2A, you see the number of publications by country of first authors affiliations for the 15 highest values. About half of our works were developed in US and Chinese institutions, while the UK, Japan, the Netherlands, Australia, and Italy together accounted for 26 of all publications. At a bigger geographic scale, and by descending order, Asia accounted for 36% of publications, followed by the Americas with 33%, then Europe with 26%, then Oceania with 4%, and then Africa with 0.23%. Finally, in terms of journal of publication, the studies were published in 111 journals, which is a high number and probably indicates that the topic of numerical models of aquatic vegetation fits in a broad research scope, mostly on the topics of water and environment. Roughly half of the publications were published by journals shown in figure 2b, which are mainly specialized in fluids, hydraulics, coasts, and geophysics. So wrapping up, this study presented a brief analysis of research on the topic of numerical models of aquatic vegetation based on 405 studies retrieved from 1980 to 2022. The data suggests that research interest on the topic keeps growing. Open access publications may outgrow paid access publications in the near future. US and Chinese institutions contribute with the majority of publications, and studies have been mostly published in journals specialized in fluids, hydraulics, coasts, and geophysics. Thank you.
Thank you very much, Thais. We go to the next presentation, which title is Prediction of Water Quality Parameters in Reservoirs through the use of satellite images and machine learning models. And the presenter will be Laura Cáceres Jiménez. And you have the floor, actually.
Thank you very much. Good morning, everyone. My name is Laura Cáceres, and I'm a PhD student at the University Polytechnica of Madrid. Today, I'd like to present you my work related to the prediction of water quality parameters in reservoirs through the use of satellite images and machine learning models, which has been developed using water quality data provided by Canal de Isabel II, which is the water utility managing the integrated water cycle in Madrid, in Spain. In this project, the objective was to create different machine learning based models to estimate three parameters: turbidity, water clarity through Secchi indicator, and chlorophyll A concentration representing phytoplankton biomass. Using the raster values collected from the images of the satellite, of the Sentinel-2 satellite, which belonged to the Copernicus program of the European Space Agency, and field data collected from 2020 to 2022 in 10 reservoirs located in the central region of Spain, near Madrid, as you can see in figure 2 of at the right side of the poster. The purpose of these models and the use of the satellite information was mainly reducing costs associated to field monitoring actions and better controlling the evolution of the water quality, of the quality state of the water bodies of the study. To fulfill this objective, we have followed the process described in figure 1 on the top left side of the poster. Firstly, we have processed the satellite images, including the downloading and grouping the images to cover all the study area in a single one, then cutting and extracting the bands information only for the reservoir surface to speed up the process, since the original images were very heavy and it would take hours to do the whole procedure. Afterwards, we extracted the pixel values of the 13 images that are collected by the satellite, reflecting in the different range of the visible and infrared spectrum, and combined it with the data collected in the field. With this information, we considered two approaches for modeling. The first one was using simple linear models with band combination using formulas obtained from the literature, which are mainly based on the water column reflection of the different bands. And on the other side, you try to create more complex and non-linear machine learning algorithms using random forest, which is an algorithm based on the combination of decision trees, and is considered one of the most robust machine learning algorithms, since it provides good results without having to perform significant calibration action. In figure 3, which is shown at the bottom of the poster, it shows the main results we got from the model using random forests for the 3 studied water quality parameters, as the results of the linear models were not accurate enough, and obtaining a correlation coefficient of less than 50% in all the cases. So with for these random forest models, we observed in the graphs, the observed values are registered in the x-axis, while the estimated values are recorded in the y-axis. So the first graph on the left side represents the result for chlorophyll A, which is of the 3 parameters the less accurate model, with an R-square of 58%. This was expected as these parameters depends not only on the number of phytoplankton and algae present, but also on the dominating groups, each of which produce different concentration of this chlorophyll pigment, and therefore is more difficult to generalize a single behavior throughout the year. In the center, in the graph at the center, we have the water clarity measured with the Sekidis depth, and we obtain an R-square of 71% of accuracy. And finally, at the right side, we have turbidity, which shows the best result with an R-square of 92% of correlation between the observed and estimated values. With these preliminary results that we obtained from the first study, we conclude that the use of these Sentinel-2 satellite images combined with these machine learning algorithms can be a promising strategy to estimate short-term changes in the water quality of the studied reservoirs. However, the acquisition of additional data, which is already being performed, and the consequent recalibration of these models, of course, we expect to improve the current results, covering in more detail all the data range, since the highest data in all the 3 parameters were the less correlated ones. And thank you for your attention.
Thank you very much, Laura. And so we can go to the last presentation, and then we will try again to conclude the presentation from Champa, if possible. The title of the next presentation will be Lagrangian particle tracking model in Sergei, and the presenter will be Pablo Valles.
Hi, can you hear me?
Yes, clear.
Okay, perfect. Thank you so much for giving the opportunity to present this work. I'm Pablo Valles. I'm a student from University of Zaragoza and University of Po, and I'm going to talk about a Lagrangian model for particle transport in Sergei project. So why do we want to develop a Lagrangian model for the rich transport? Well, flooding events are one of the most destructive natural disasters, causing a lot of human and economic losses, and in the last decades the frequency have increased. So governments and institutions must develop plans and tools to foresee and to mitigate the negative effects of these events. And one of these tools is the use of predictions based on numerical simulations. So in the most recent natural disasters, we can see that it's not only important to obtain the temporal and spatial evolution of the flow, but also it's important to obtain the temporal and spatial evolution of the breeze, because they are one of the most frequent causes of death during a flash flood, and also because they can obstruct the hydraulic structures such as a bridge, and they can increase the water level, and therefore they can cause more negative effects during a flash flood. So the idea is to develop a tool to simulate the temporal and spatial evolution of the flow and of the debris that are transported by the flow during a flash flood. So this Lagrangian model is implemented in the Sergei framework project, that it's an open source code and is based on several modules. For instance, an hydrodynamic model to obtain the temporal and spatial evolution of the flow, other module for the sediment transport, other for the vegetation. So the idea is to develop this Lagrangian model as a new model for Sergei. One of the most interesting aspects of this project is that it's implemented using MPI. So you can use CPU or GPU or multiple CPU or GPUs, and it's implemented using Cocos language. So using Cocos language, it doesn't care the architecture of your GPU, for instance, or if you are simulating using a CPU or GPU. So we have only a code, and with this code, we can simulate using different sources. That it's really interesting aspect for us because it's an open source code, and people around the world can collaborate with us without problems using this Cocos language. So in this moment, the Lagrangian model is in a beginning step. So we can simulate particles with an negligible mass and volume without interaction between them, and they can't change the flow properties such as viscosity or density. And as we can see in the screen, the particles trajectory are obtained using this equation that is based on the advention. So we obtain the velocity of each cell of our mesh, as we can see, and this velocity is provided by the hydrodynamic model that Sergey has. And the second term that is in blue, it's the turbulence term that we have added because the hydrodynamic model doesn't solve the turbulence because the turbulence isn't relevant in the majority of cases. So the idea is to add this turbulence in our Lagrangian model instead of solving in the hydrodynamic model because we have seen that it's more efficient. So with these trajectories, we have implementing for one CPU or one GPU, and we have done several test cases to validate our model. And finally, we have simulated a real case that it's the Arnas catchment that is in the north of Spain, and we have simulated a precipitation event with different number of particles, and we have obtained logical trajectories for our particles, and we have done a sensitivity analysis with different number of particles, as we can see in the top right, and we can see that the increasement of the number of particles doesn't produce a really high increasement of the computational cost. So the conclusion of this work is that the Lagrangian model is efficient and accurate, but it needs a harder validations with test cases and using real test cases. That it will be really interesting for us. This Lagrangian model must be extended for large debris such as cars, waste containers, or boulders, and also for other kind of debris such as microplastics or sediments or pollutants. That it will be really interesting. And finally, we must implement this Lagrangian model for MPI, because as I have said, we can using this Lagrangian model one GPU or one CPU, and the idea is to extend this Lagrangian model for MPI, and that's all. Thank you so much, and if you have a question, you can ask me.
Thank you very much. Before starting with the discussion, we should try to get back to the first presentation and see if we solved the initial problems with the network connection. Shampa, can you just conclude on your work that is related to riverbank erosion?
Yes. Yeah. Thank you, Chair, for giving me the opportunity once again. Can you hear me clearly?
Yes, clear. Very clear.
Okay. So though I am studying, though riverbank erosion is a very natural process of alluvial river, but in case of the downstream portion of braided river of Brahmaputra, Jamuna, here in Bangladesh, it's a make disaster because many people lived in the river banks and the river bars. So if we have an prediction systems of erosion, it can save their land and their homestead. and that's basically the motivation of our study. But the main problem is that if we are like predicting the riverbank erosion through numerical model, the bathymetry of the braided river, it's very it's quite costly, and in Bangladesh there is no tradition method that can capture the river bathymetry in braided scale. That means like it can consider the confluence and the bifurcation. The usual bathymetry generation taken by the Bangladesh Water Development Board, it basically 6 kilometer to 4 kilometer apart. So it doesn't create the proper bathymetry of the river. So therefore, due to lack of this, the prediction systems basically fails. And in Bangladesh, there is no system basically for the riverbank erosion so far. So here is our the attempt to develop a numerical model based bank erosion system, and for this we use the remote sensing based technology, and we use the Landsat image and take the band of NIR and green band. And if you are interested, you can see our abstract for the detailed methodology of the developing the braided river bathymetry. Previously, literature like Lysinga or stuff, they produce the bathymetry of the riverbed, but we tried it, but it basically doesn't produce good result for the braided river. So we use relatively newer approaches for the generation of the bathymetry, and we this dry season bathymetry we use as the base input of the numerical model. So as a numerical model, we developed a two-dimensional morphological model that basically solves the Navier-Stokes equation as well as the sediment transport equations. And you can see our figure 2, sorry. Here is the snapshot of our web portal. So from the numerical model results, we developed one API that is integrated with Google Map. And if like any people who is living in the river bar area or the bank area, they can see whether their homestead or the lands going to the river or not. And we tested our method for the field testing for the year 2003 and previous 3 years from 2017, and the accuracy we found that it was nearly 73 to 74%. So as a conclusion, we are still developing our accuracy of our model, and we think that it can be a tool for giving the people the proper information for the river erosion. Thank you.
Thank you very much. And well, we are pretty in line with the program. So Arianna, how we will or Manish, obviously, how we will handle the discussion now? We can start now. We can wait for a few minutes.
I think we can start now, and yeah, and maybe go round through the posters. And if it's okay, since we are like in a small break, I would ask everyone to turn on their camera so that we make a snapshot of this session. And waiting for the last ones. Okay. Okay. So 3, 2, 1, smile. Great, thanks. Okay, we can start the discussion. Yeah.
Okay, perfect. Do we have questions from the audience, from the chat, or we can start the discussion and then we will see? Just to ice break the discussion, we had some pretty interesting applications, some general tools and some reviews in this session, but all of them have had to cope with data, obviously, with the application of models. And I wonder if you have any general thought about data needs and data quality that you handled in your research, and how your tools were able to handle errors in data. Did you do any pre-treatment of your data? Do you have to cut a part of the data to go on and apply your tools or whatever? If you have some comments on the data problems. Anyone willing to start?
Well, thank you for the
Pablo.
question. Yeah. In my case, I use the data, for instance, for the topography and for the ruggedness, but instead, there is a difference between my model and a model based on, for instance, neural network, because we need essential information, but this is validated, for instance, for the Institute of Geography of Spain, for instance, but we don't use real data of the debris transport of the last events. For instance, we use real informations, and with these informations we simulate our Lagrangian model, and with real events we can validate our model, but we don't change we don't have a training state that other models has. But it's important, the aspect that you have said, that it's really important to do a pre-process to know if the data information is correct or not, because, for instance, in the topography we can see several times that there are a lot of errors that can produce errors during our simulation. So we must do a really hard pre-process to know if the information that we have used is correct or not, and then we can simulate with high security. But the pre-process is really important for us. Thank you.
Thank you. Any other comments on the data issue?
For example, well, I didn't have any errors, but I mentioned already in the presentation that I used satellite images, which are very heavy, and one image has thousands of pixels. So it was not in the process of calibration, but when using the model to transform the original values of the images to water quality data, but I have to cut the images only to the reservoir I was studying, because it was so slow, the process, that it would take like maybe a day to do the calculations for the whole image. So for me, it was really, really important, this pre-processing, as cutting and selecting only the pixels that I was interested in to make the calculations.
Laura, did you have problems with clouds in your images?
What do you clouds? You mean to download the images, or
not to
cloud covering?
To clouds cover. Yes, sorry, I was. Yes, it's one of the main problems of using these images from the Sentinel-2, because as it's affected by the clouds, because the optical sensor is not able to trespass the clouds. So the days when I had clouds, it was not possible to use the data. It is one of the main issues of this kind of images.
Other comments or issues?
I guess I can comment on the development of what I did. So my work is mostly based on web stuff, right? So I connect to APIs around the world. And one of the case studies that I developed for the project is connecting to USGS daily values from Streamflow. And again, I guess the problem is the reliability of this data. Many of this is statistically derived, so they applied a lot of models, and afterwards those outputs given out, or they are observations. But then again, these observations, many times, if you don't do a correct job at the pre-processing part, you're going to get this stepwise executions on the results, which are just highlighting that there's non-values, or that the information that you're inputting into the I don't know, frameworks or whatever that you're using is going to be a problem. So what I did for that was I was mostly leaned towards even if it's not observed, at least statistically derived. I guess that gives me a little bit of reliability. Specifically because what I was trying to do was for many stations around IO, which is actually pretty good in the networking part of sensor information. From the 1900 all the way to 2023, it's around what, like 70,000, 80,000 per station for 250 stations. So that's quite significant number that might cause an issue when dealing with those results. So adding more data sources, that's actually a way I kind of cumbersome that kind of part. So just to evaluate it, but yeah, definitely the pre-processing requires more work.
Other comments from the other applications?
Okay, if I can say, in my case, the data of the dataset are generated with a numerical model. So my surrogate model is trained on data which are not observed, but are generated. So in this case, we have the problems that Pablo already said. So the bathymetry, for example, the data we use is data from a LIDAR sensor. So this must be modified to remove different problems. And so this is the first step. Then we have to calibrate the model. So define the value for the friction coefficient, which is a parameter for the data, the numerical model. And so these are the some aspects that can generate an error in the map that we use as ground truth, so as the real data, because my model, so the prediction of my model is compared not to the real observation, but with the result of numerical simulation.
Very good. And other comments? Okay, then, well, I actually have another general questions to all of you. That is more or less something that we learned from hydroinformatics in these last 20 years. Hydroinformatics started with the willingness of using these very good, very efficient machine learning approaches just to make our predictions better. But then one possible pitfall that all of us have using these tools is that we can rely too much on machine learning, losing the knowledge, the hydraulic and the hydrology knowledge that is behind. So I would like only a comment from you on how important is to look at these tools by remembering your knowledge in the field, in the hydrology field, in the hydraulic field, just not to rely too much on computers. Do you have some comments on that, or do you feel that your tools are good and really?
For example, yeah, it's a good question because it's a problem, and I have to overcome this problem because the results are not so good, and maybe neural networks, and so artificial intelligence in general is can be complex and not all the time as there is a way, there is a reason why the model is making us some prediction or making an output. So it's important to try to add a base of physics in these black box models. It's not always easy, but I think it's important.
Yeah, I agree with you, Gabriel. And also, I would like to highlight that they are very useful, these kind of models, machine learning models, of course. They are able to capture very complex relationships that maybe with numerical modeling is very hard to formulate this kind of complex processes. But I absolutely agree with your comment, and in my department, we apply machine learning to many fields, and we have one thing that we try to maintain that regardless the project, we have to have in our teams specialized people that know about that topic. We can build very complex machine learning algorithms, models, but we have to know how to interpret the results obtained. And without the knowledge of the specific expertise, these models could, as you are arguing, they could give us a result that we cannot trust blindly with those results. No, so I totally agree, and that's one of the main limitations of machine learning model for some people that are considered to be a black boxes models. But they have this advantage of capturing these complex relationships that are very difficult to simulate in other occasions.
David, thank you. Shampa, you raised your hand.
Yeah. I want to add my experience and that I am working with the riverbank erosion. So riverbank erosion has some patterns, but while using only machine learning for analyzing these patterns and the prediction of the future, and we saw that many machine learning models fails because it cannot address the places where there was no like erosion or the hazard before. But as a dynamic system, and we have the climate change and the disaster intensification. So in my research field, I saw using the machine learning, these components basically missed while you're using only machine learning. So I guess we may have built a very complex model or very useful results, but we should take into account that our systems is changing. So we should be careful of that. Thank you.
Yeah.
Thank you, Shampa. David.
Yeah, that's another limitation of machine learning as relating to this comment of Shampa is the difficult, the main drawback of many models, database models, as they are based on data and observed data. It is very difficult to predict, to forecast the most extreme ranges of our behavior, of our process, and also to simulate extreme events. No, so that's a very particular area in machine learning, in the machine learning field, that is very interesting to deep in with more deep. And I would like to ask you, most of you of the speakers, if some of you we have seen in your nice presentations that some of the results have been have the limitation to predict that extreme ranges, no, that you are trying to predict. So have you handled in some way this topic, or are you planning to introduce some algorithm or some pre-processing technique like related to imbalanced data sets to improve the forecast of these ranges that are not well. We have very low data to represent them.
Well, I already mentioned also in my presentation that I have issues with predicting especially chlorophyll A in the highest ranges because it's very difficult to collect samples from these days because of the cloud. The weather condition has to be fine, and also only in the summer months we have high concentration of chlorophyll. So what we are trying to do is collecting more samples, but also trying to use some also techniques to get artificial data, like to simulate a high chlorophyll concentration, to try to modify the values of the obtained from the model to get better results for these values, because it's at least in my case, if one of the main limitations of the algorithms, the models developed.
Thank you, Laura.
Thank you. Other comments on this theme?
If not, Gabriel, I think that we have some specific questions in the chat. So if there are no more comments, we can read these questions, maybe.
Yes.
Okay.
Just go, David.
Yeah, Gabriel.
Yeah.
Okay. There is one specific question to Pablo Valles. Okay. It's made by Mohamed Osair. And the question is in relation to the Lagrangian models that you have presented. Can it be used in combination with the HERRAS software?
No, you can use Sergey, that it's an open source code. You can download it and you can use it. Well, I can send the website and it's really easy to use it. But no, we don't collaborate with the rats. Sorry. But well, the idea is to obtain an open source code that people around the world can collaborate with us to create a big project. Thank you for the question.
Thank you, Pablo. I think there is
another one. Yes.
Yes.
For Shampa.
Oh.
What are your thoughts on utilizing the Google Earth engine for remote sensing applications?
Okay. Sorry.
No, I was not sure if it was for Sampa or for me because I also use the images, but let's Sampa answer you.
Okay, yes, using the Google Earth engine, Laura, yeah, I can share my experience, so you can be the next one. So using the Google Earth engine, yeah, it's very good for for analyzing our for remote sensing analysis, and what I want to say that we can compute very quickly and very fastly using the GEE, and in sometimes while making API based application that at that time GEE is also very useful. So, I can say that in future we should focus on it. It's very handy and useful, I guess, for remote application. Thank you.
Laura, do you
want to add? Yeah.
No, I wanted to add also because I also do like remote sensing, and but I don't use. Well, I know how the power of Google Earth Engine, and for me, it's one of the most powerful tools to do this kind of analysis. But based on my experience, the problem is that you don't control what is happening there and the data you upload to the cloud. So in my case that I use data that can be sensitive from a company, I prefer to do it like in my servers instead of using Google, just for the people that wants to use Google Earth Engine to take into account.
Okay, any other question?
I have a short question for Laura. Well, maybe you have said, but have you thought about the idea to extend your work for microplastics concentration or not?
Well, I hadn't thought of microplastics, but I had the idea to extend the study for other water quality parameters. So now you gave me a really good idea.
Okay, thank you. For me, it will be really interesting.
Yeah, I mean, you can check in the literature parameters related to water quality that have been already studied, but I mean, the scope is amazing, so you can do whatever you can think on. So yeah, if someone is interested in microplastic, if the image can capture something that can be tasks, it would be really nice.
Okay, thank you.
Thank you for the idea.
Very good. Other comments, even cross questions are good, obviously.
Yes, that would be nice.
Carlos, I have one for you, actually. Yours is actually one suite of tools, right?
Yes.
You have many tools. But I wonder, again, thinking about data availability, how this suite of tools is able to cope with small amount of data, average amount of data, very large data sets.
Right. So let's see. That's, I guess, a limitation of web browser technology, and one of the main things that I'm trying to explore. So, traditionally what we do is server-side stuff, right? Because in the server, you can run very heavy computations with large amounts of data. So one of the projects that I'm working on right now is in the development of peer-to-peer communication using both servers and peers to transfer and analyze information on the fly. What I'm doing is trying to rely mostly on the hardware available on the user's end to process this data. Process this data means, if you're trying to run a model, if you're trying to do some machine learning stuff as well. All of these very nice tools that are available out there, probably the people who have done a lot of machine learning already knows about this TensorFlow and all these very nice libraries. You can leverage that now on the web browser, but more importantly, you can remove a lot of the server-side connectivity to create more of a decentralized system. And that is one of my focus on the PhD as well. And we're trying to create, again, a set of tools that does all this information analysis for hydrology and environmental sciences within the scope of a decentralized system that is strong enough to be its own thing, right? So the tool that I showed today is one of probably 4 or 5 that I'm going to be highlighting in my dissertation. And what my focus is on, yes, this big data processing, but leveraging as much as possible, implementing as many efficient and state-of-the-art algorithmic techniques to create a nice stream flow for this information. So definitely I understand there's a lot of limitations in terms of how the data is processed. I mean, how many of us have gone through a web browser and the web browser just gets freezed up? And that's because many of these technologies are just working on one single CPU thread. So now with the advancements of new technologies, we're able to leverage a lot of our computational resources for a better usage of this very cool and very state-of-the-art technologies. So yeah.
Thank you. Any other comments? Well, actually, Ariane, I'm sorry. I have another question for all of you. You are young. There is a very pretty initiative from IAHR about the ability of our community to cooperate with IPCC on climate change. Probably this will be the first time that the community will go to the COP to give our ideas about climate change. And I wonder, in your experience, in your activities, if you have any thoughts on what is missing in our ability to cope with climate change in our tools. David just a few minutes ago told us about the need that we have using machine learning to have stationary processes, but we will not have stationary processes. Do you have any experience on the use of artificial intelligence with some non-stationarities, with climate changes in general? Any comment on that? Well, probably we had to work a little bit more. Okay. Very big question, I think. Fine, and David, I think we can, well, there is a raised hand from the audience, right?
Yes. Exactly. Samuel Negosi. Samuel, do you want to make some question?
I think we had one already. That was one regarding the Google Earth Engine. So I think.
Okay.
And then we
Yes.
have another one in the Q&A now.
Question for the host.
Yes.
Okay. As part of the IAHR Young Professional Congress, we are eager to learn about the contributions you are making to help. Okay. To help researchers and professionals in developing countries enhance their research skills.
It is for the host, so I will start with commenting on wording. I don't think developing country is, I don't like it. Okay, sorry.
Emerging countries.
I mean, we go on into a discussion that's very much philosophical. And I would ask our chair of the Congress to intervene on that, because we have him online. So I think he's the best person to answer this question. My understanding is that this conference is built for allowing more people to participate in IAHR related events, but please, Michael, complete.
I mean, that's a key point of this Congress, is to allow young researchers to interact with more senior people to help developing not only countries, but also teams, like Gabriele pointed out about climate change. We are willing to hear any feedback from all the young persons which are in the speakers for this session, but also in general terms, all the attendees from the other sessions as well. So, well, and then in terms of if you call it developing countries or whatever you want to call, which we can discuss further on that.
Okay, perfect. I think we are coming to the end of the session. It's only 4 minutes to the official end. So if there are no other urgent questions, we can conclude.
Yeah, I think we went through all the questions in the Q&A. And since it's not 3, you can still grab a physical coffee. It's not going to affect your night sleep. So yeah, it was a pleasure to stay online with you. Thank you for attending and thank you for presenting and sharing.
Thank you to
all of
all
you.
and good luck.
Thank you all.
Thank you.
Good afternoon and good morning. Good morning,
Hi,
good afternoon, and good evening to everyone. We are beginning this session in 2 minutes. So I think that we can start. Again, good morning, good afternoon, and good evening to everyone. My name is Gaetano Crispino. I am a member of the organizing committee of this, let me say, amazing Congress. And this is the session on flood risk management. The session will be chaired by Professor Stefan Haun, who is the head of the Hydraulic Laboratory of the University of Stuttgart in Germany, and Professor Daniela Molinari from Politecnico di Milano in Italy. I would warmly thank the professors Haun and Molinari for accepting our invitation to head this session. And obviously, many thanks also to all the authors of this session who will present their posters. My colleagues and co-hosts of the session, Arianna and Jose Carrillo, will load the posters speaker by speaker at the beginning of each presentation. So each author will only need to switch on the camera when his or her round will start and present their own work. I give now the word to the chairs of the session. So please, Professors Aun and Molinari, the microphone is yours. Thank you.
Okay, thank you, Gaetano. Welcome to everybody. My name is Daniela Molinari. I'm, of course, professor of Politecnico di Milano, but I'm also chair of the Flood Risk Management Technical Committee of IAHR. And this is the main reason because I'm here with Stefan Hohne, that is the vice chair of the Flood Risk Management Technical Committee of IAHR. For who is not familiar with our committee has the objective of offering a platform for everybody that is interested in flood risk management or that works on flood risk management or do research on flood risk management. We offer this platform by offering different kinds of opportunities, so seminars, conferences, special sessions at conferences, the opportunities to be involved in some of our initiatives. One of them is in place. And for example, in the past years, we have published 2 papers on the role of hydraulic engineers in flood risk management and on the links between flood risk management and sustainable development. So everybody is welcome to join us as a committee, and because you are working on that. And this was simply an introductory speech. Then the session will be actually chaired in terms of presenting contribution by Stefan. That will give you also the time for the presentation. And then at the end, we will have a common discussion leading by the 2 of us. So after this welcome speech, I leave the floor to Stefan for the ongoing of the session. Okay, thank you, Stefan.
Thank you very much, Daniela. Also from my side, a good morning, a good afternoon, and a good evening. I need to say that, or I'm proud to say that, because I saw that we have speakers from Malaysia, from Spain, from Italy, from Canada, and from Peru. So we are really spending the day, the whole area, spatially distributed. But I think when I read the topics, we see that we have also different temporal scales, what we will hear in the next minutes. So the speakers have 3 to 5 minutes. In our case, I saw we only have 5 posters. Ariana, is that correct? You looked very critical.
I'm doing something else, like adding authors. But we have, from the program online, we have 7.
Yeah.
And we have 1 more, if I'm not mistaken.
Yes,
I will confirm on that.
Exactly. I saw that on the webpage there are 8, but only 7 abstracts. So, but I just wanted to say for the timing, I think we can go up to 5 minutes.
Yeah.
And at 5 minutes, I will raise my hand. That would be the sign for you to come to the end, to make a closing remark, and then we will discuss that afterwards. One important thing, if you have questions, write them in the Q&A, because otherwise we are losing attention, we are forgetting things. So in my age, it is very common to forget things. So write it down, and afterwards we will have a very nice discussion and hopefully a fruitful discussion with all of you. But I think now we have said a lot of things. It's time for you to present us something. And I have seen the first presentation. It's about identification of flood extent of Panataran River in Kampung, Melangkap, Sabah from Malaysia. And I have seen the speaker, Rosdiana. The floor is yours, please.
Thank you, Chairs. Sorry. Hello, everyone. Can you hear me? So hello, everyone. I'm Rosdiana, a PhD student at University Malaysia Sabah. I would like to share with you guys about the preliminary study that I did for my research on Panataran River in Melangkap, Kota Belud, Sabah, Malaysia. I have interest on this river. I have interest on this river because the river was altered morphologically after a seismic debris flow in 2015, where the river corridor was expanded and more sandbars were formed, improving its aesthetic. The local communities in Melangkap then took advantage of of this to establish ecotourism activities such as homestays and camping sites along the river, using the Panataran River itself as the main attraction. This brings wonder if it's safe or for the locals, or are they vulnerable to flooding from the river. By using historical flood extent, I aim to identify the maximum flooding extent of the river, and most importantly, if the local communities and their established ecotourism activities are within the flood extent. So to do this study, I obtained satellite images for 5 selected years from Google Earth Pro, which are 2011, 13, 14, 16, and 19. I digitized flood extents at both banks, north and south of the river, as shown in figure 2 in the poster, which helped me to identify the maximum flood extent. Once I've identified it, I digitized the maximum flood extent for the river. So what I found was that there were not many changes before the debris flow event, except slight extension inland in 2011. And then after the event in 2016, which is actually a few months after the debris flow event, the river corridor was the widest due to the river's lateral mobility as sediment and debris eroded the banks. This meant that the flood extent was further away from the center of the river. The river also underwent channel adjustment throughout the years afterward, which likely due to the river's grading characteristic of having diffusing nature. It could also be the effect of human intervention, as I mentioned earlier, that the ecotourism activities are increasing along the river. The maximum flood extent that I have identified and digitized is shown in figure 3, and the local communities and their ecotourism activities are within the flood extent. This indicated that the local communities and the established ecotourism activities are indeed vulnerable to flooding. Hence, it can be concluded that from the identification of the maximum flood extent of Panataran River, the local communities in Malangkap and their ecotourism activities are vulnerable to flood. As part of the next step in my research, I will be validating this historical extent using computer modeling software, as this is a serious matter for the local communities. So that's it from me today. Thank you for listening, and thanks once again.
Thank you very much, Rosiana. Well in time. Just as a small reminder, if there are questions, please write them in the Q&A, and we will then discuss all your questions. And I'm pretty sure that also we have some questions for you. Thank you for the presentation. Then we will go to the next presenter. It's the analysis of the influence of the design heterograph shape on flat hydrographs. Daniel, he's coming from Madrid. By the way, the floor is yours.
So you can hear me? Okay.
Very well.
Okay, so my name is Daniel Carrier Rojas. I'm from Universidad Politécnica de Madrid. I'm going to present the first step of my study. I'm a PhD student of first year, and I'm going to present the analysis of the influence of the designator of shape on fluid hydrographs. So as introduction, it's generally accepted that hydraulical frequency analysis are based on univariate approach with fluid peak time series. For example, this is the case for Moss Bridge and Calvers, but this is not the case for the dams, where it's necessary to consider the entire fluid hydrographs characterized by fluid peak, hydrograph volume, and hydrograph duration. So we need to perform a multivariated analysis. So the main objective of this study consists in performing hydrometeorological simulations to assess what's the influence of hydrograph shades on hydrograph shades. So this work was done in Corda del Pozo Dam in central Spain. It's a dam that belongs from the Douro River, Douro River basin to origin. And so in the methods, we use the recorded data in the reservoir to obtain a fluid peak frequency curve and the raw volume frequency curve. And we use these two frequency curves to calibrate the model. The model is an hydrological model, HEC-HMS, that is a rainfall runoff model. And in this model, we introduce the hydrograph that are obtained from the rainfall data obtained in the IMET. So within the HEC-HMS model, we perform a hydrometeorical simulation to obtain a fluid hydrograph. In the fluid hydrograph, for each return period, we obtain one fluid peak and one hydrograph volume that are given by the frequency curve, the fluid peak and the hydrograph volume. The hydrometeorical simulations are carried out based on the curve number method and the current unit hydrograph that is used as a transformation method. And the SIN hydrograph is the Chicago hydrograph shape based on the intensity duration frequency curve. In the Corda del Pozo Dam, the annual maximum fluid hydrographs are usually generated by storms lasting about 10 days. So for simulating such a long hydrograph with a hydrometeorical model, the selection of the hydrograph is so important because the hydrograph shape will be influenced by the hydrograph shape. So we can see here in the middle, in the results, that we have performed the study, we have calibrated the model for the 1,000-year return period. And what we have done is we choose different time steps that are 1, 2, 3, 6, 12, and 24 hours. And for each time step of the hydrograph, we obtain an hydrograph shape. So we have here the first figure in the center that before calibrating the model, we can see that for small time steps like 1 hour, we have sharp hydrograph with a high value of the fluid peak. In contrast, for small time steps, like also for large time steps like 24 hours, we can see here in red, we obtain a smooth hydrograph with a small value of the fluid peak. So then we calibrate the model. We calibrate the model with the K parameter, that is the storage coefficient parameter in the Clark unit hydrograph model. And with this parameter, we calibrate the fluid peak. So for example, in the 1,000-year return period, the fluid peak quantile is required is about 900 cubic meters per second. So we calibrate the model with the K parameter calibrated. We obtain that in the figure below that for the 1, 2, 3, 6, and 12 hours time steps, we obtain similar hydrographs. There are similar hydrographs with the same shape. But for the 24 hours time step, we obtain we have also for the 24-hour time step, we cannot calibrate the model because we don't have any value of the K parameter that allow us to reach the fluid peak parameter required. So as conclusions, the selection of the hydrograph time step is crucial. As I said before, that before calibrating the hydrological model parameters, smoother hydrograph shapes and lower peak flows are obtained as the hydrograph time step increases. And after calibrating the model, the calibrated K parameter is smaller as the hydrograph time step increase. So in addition, similar hydrograph shapes are obtained for all time steps, except for 24 hours with the parameter K calibrated. As I said before, for a time step of 24 hours, the hydrological model could not be calibrated. So this is all. Thank you.
Thank you very much, Daniel, for the interesting talk. I told you that we will have a huge variety in talks, so I will announce the next speaker. It's the evaluation of mud flow and debris flow hazard in the Los Incas Basin in the city of Arequipa. I hope I pronounce it correct, in Peru. Joel, are you here?
Good morning. Can you hear me?
I hear you. Yes, we hear you. The floor is yours.
Okay. Thanks. My name is Joel Puma. I am civil engineering in the Catholic University, Arequipa, Peru. This study presents the result of the accuracy of mud flow and debris flow resulting from extreme rainfall. Peru is the highest exposed to climate change, with effects in several and occurrence of meteorological of phenomenon of El Niño. A situation that aggravates the situation, quality, poverty, and population growth. The time series of precipitation de la Fontilla Station in Arequipa and span for 2 years from 1981 to 2022 has been used a general flow hydrograph usando HMS model, considerando ES2 profile stock. The parameters of The rollout model has been characterized version of mechanical study and point critical. The hydraulic model has been calibrated using historical events with the new force, the new Newton's and IGRAS. Finally, flux hazards must be grabbed in here. The methods, the historical flood events, 1995, 1997, 2001, 2008, 2012, 2013, and 2029, and the 2020. In the last event, we count characterize the maximum support with precipitation, the right of the representation in Arequipa, Peru. Used 42 years of comfort at the 1981, 1982, from 50,340 data points. The application of the trails, as you can see, the feature one, maximum precipitation results at the quantity station for water, moderate rainy, very rainy, extremadamente rainy. La frecuencia de análisis can use data use and no parameters, which as Epsilon Kolmorov. The case of significantly less 5% to determine the distribution function from the best, the maximum data series. Get. Low results. We can see in feature 2 the torrentera Los Incas most and model in Los Incas string use XRAS. Los Incas string from critical point solve mechanical schools exhibition and higher percent and the weak 6. 50% compared to the gravel, 30%, cobbles 50%, and soil results 5%. There are the various approaches to non-Newton fluid for the study. A monophasic approach was employed involving regular parameters from the XRAS model, which are the basis and non-Newton algorithms in the result in XRAS. As you can see, picture number 2. Conclusions in the first, the volumetric concentration has a significant impact on both individual stress and the dynamic viscosity as evidence of sensitivity analysis and the RS taxonomy. The second, the Los Incas system does not have water of the sediment insured. However, the hydraulic model was calibrated the water from the left, the historical events, and 2022 two-dimensional simulation with a parameterization typical soil and the Rayleigh equation model quadratic for mud and debris flow. Thanks.
Thank you very much, Joel, for the interesting talk. I'm pretty sure there will be a lot of questions because like changing the property of water in HEC-RAS is quite a new possibility where we see now first studies. So I'm pretty sure that there are a lot of questions. When we talk about questions, don't forget to write them in the Q&A channel so that we have them afterwards for the discussion. We jump to the next speaker. We talk about, or we hear about, exploring flood zone with prediction using multi-objective evolutionary polynomic regression. Mohamed Azaourou. Do I see you here? Here he is. The floor is yours.
Hello, and welcome to this presentation. I'm Isa Ebtahaj, and I would like to present on behalf of my colleagues. Flooding, as one of the deadliest disasters, is the most frequent national hazard to the environmental, infrastructure, property, economy, and life around the world, especially in Canada. In last 120 years, there have been 62 significant floods in Ontario with damage ranging to $1.2 billion. Previous studies have shown that machine learning algorithms are good at predicting floods, but their accuracy depends on historical data used for training. However, it's important to note that this algorithm can predict floods that have never happened before. Climate change has led to notable alteration in flood patterns in Canada, so that the 2019 flood exceeded 100 years flooding. To address this challenge, we have combined numerical modeling with machine learning. The study focused on Rideau Canal in Ottawa, Canada. The Rideau Canal is a 202-kilometer long canal that links the Ottawa River with the St. Lawrence River. The primary uses of this canal are water level management, boating, tourism, and also winter skating. The methodology for estimating flood zone width in the current study involves several case steps. First, a cross numerical model is calibrated using available information about the Rideau Canal. The second step involves validating this calibrated model. Subsequently, the calibrated model is authorized to generate a dataset incorporating unexperienced discharge with a maximum value of about 1,200 cubic meters per second. This data set is then divided into sets, one for training and the other for testing in the machine learning process. The machine learning algorithm is trained using the input variables of slopes, coordinates, flow discharge, and morning roughness coefficient, all derived from the data set. Finally, the performance of machine learning model is assessed using the testing data set to ensure its accuracy and effectiveness in flood zone width estimation. The primary goal of evolutionary polynomial regression training is to minimize the disparity between observed and estimated values of a target variable and also determining the optimal number of polynomial terms. Achieving both objectives involves the use of multi-objective genetic algorithms. The main advantage of APR MGA are including interpretability, low hyperparameters, feature selection, avoid of overfitting, complexity control, robustness, and also efficient computing. The results of the APR MGA in flood zone with prediction provided in this table, it can be seen that the values for each index fall into the very good category according to the provided descriptive scale. Furthermore, this model is capable of predicting over of 80% of all samples related to flood zone width with a relative error of less than 20%. As a conclusion, the numerical model was employed to generate a data set for inexperienced flood. Evolutionary polynomial regression was integrated with multi-objective genetic algorithm. This model was developed for flood zone width estimation. Also, the model demonstrated acceptable performance as indicated by various statistical indices. Finally, this work goes beyond its immediate application, offering valuable tools for flood forecasting and management. Thank you for your attention.
Thank you very much, Isa, for stepping in and for presenting the study. Very nice and interesting results. We're going to the next speaker, which is also from Canada, so we don't have to travel a long way. It's about hydrological flood vulnerability mapping using GIS and satellite imagery data, a case study in Eastern Ontario. Emma Christie, the floor is yours.
Hello, do you hear me?
Yes.
Okay, thank you so
Amir,
much.
we hear you.
My name is Amir Nouri, student of University of Ottawa. I would like to present on behalf of my colleague. On this presentation, my topic is hydrological flood vulnerability mapping using GIS and satellite imagery data, a case study in Eastern Ontario, Canada. The prime aim of this study is to identify regions prone to flooding through the integration of satellite imagery data and geographic information system. For this purpose, multiple criteria, including climate, meteorological, and hydrological information were taken into account. Initially, the digital elevation model of the study area was obtained, and special layers of study area like precipitation, land cover, slope elevation, and distance from river were generated in GIS environment. Subsequently, from Sentinel-1 satellite imagery data of flood occurring in the recent year were downloaded. The downloaded satellite data were transformed using a created model builder within the ArcGIS software. Furthermore, based on the obtained climate and hydrometric data during 2015-2022, temporal layers were created to depict the spatial distribution of climate data and hydrometric information. Afterward, the Kriging interpolation method was utilized to fill the gaps of the observed hydrometric data within the study area. Each of the generator layers were categorized into 5 classes ranging from very low to very high based on the 5-point Likert scale. In the next stage, criteria importance weights were assigned to all of the created layers based on the expert's opinions. Finally, all classified layers were combined together using overlay tools in ArcGIS software to predict integrated layer as a flood vulnerability map. The final flood mapping categorized the study area into 5 primary classes. Based on the flood mapping results, the distribution of this class is as follows. Very low classes covered 8.60% of the study area. Low class encompassed 10.8%. Moderate class accounted for 16.5%. High class made up 28.6%, 60%, and very high class comprised 35.8% of the study area. The research conclusively demonstrates the effectiveness of the combining satellite imagery data and GIS for flood risk assessment in Ontario Rideau River flood subbasin. This study is refined hydrological flood assessment, including factors like land cover, elevation, and climate data, notably precipitation and soil moisture, enhance the accuracy in flood mapping. This approach involves the experts' opinions in weighting the criteria, which lead to development of detailed flood risk categories. In summary, this work not only highlights the utility of GIS and RS in flood analysis, but also provides essential insights for flood mitigation and urban area protection. Thank you so much.
Thank you very much, Amir, for the presentation. If there are questions, last reminder for you, please write them in the Q&A section so that we can have a fruitful discussion after or in our coffee break all together. We are traveling to Europe now, a model to account for the within event evolution of flood damage, insights from a case study in northern Italy. Tommaso, the floor is yours.
Thank you. Good afternoon. My name is Tommaso Lazzarin from the University of Padova. And today I'm going to present this work that is part of a larger project. And this, in particular, the work I'm presenting today aims at estimating the flood damage to buildings in a case study in northern Italy. In particular, the study makes use of an innovative model that computes the within event evolution of the damage, so how damage evolves during the flooding event. And in particular, what I'm showing today is how some topographical features may affect the propagation of the flood into the floodplain and also to affect the evolution of the damage in time. So an hydrodynamic model is used to evaluate the levee failure and to estimate the flood propagation into the floodplain. And a damage model is coupled to the hydrodynamic model. And for each building, the relative damage is computed by integrating in time the rate at which the damage progresses to the equation here shown. That has been found in our previous work and calibrated by the comparison with a synthetic damage model. And in particular, the results we obtain here have been obtained by comparing two different layouts of the same area subjected to the same flooding event. So in the upper panel here, there is the 1999 configuration of the area, and in the panel below, there is the 2004 layout. And the main difference is this secondary levee highlighted in pink, that it was continuous in the first layout and discontinuous in the second layout because of some works for the passage of a new road. And so, analyzing the water depths and velocity maps, we observed a different propagation of the flood, as in the second layout, the flow can propagate in the southern part of the area, and so the water levels are reduced in the northern part of the area, and the buildings in the southern part are reached earlier in time in the 2004 layout. And these affect also the evolution and the propagation of the damagement process, as, for example, in the same instant, the buildings highlighted with the pointed by the arrow are not damaged yet in the first layout, but are still damaged in the second layout, and thus there is a different evolution of the damage. Such a model also allowed to investigate the temporal evolution in average terms, so for the entire area. And for example, in the graph in the panel C, you can see that the damage progresses faster in time in the 2004 layout and slower in time for the 1999 layout, but the final value of the damage is lower in the second one. So this work highlighted the importance of evaluating the dynamics of the flood processes, also accounting for secondary topographical structures, because they affect the flood and the damage propagation, as in the present case, the interruption of a short segment of a secondary levee modified the flood propagation and the dynamics of the damage for the buildings. Of course, to perform this kind of study, hydrodynamic models and bidimensional, at least, hydrodynamic models are required to represent the flood propagation and to highlight the role of such structures. And also the damage model we developed that account for the evolution within event can properly use the data obtained from the hydrodynamic model to translate this information into the assessment of the damage. And that's all. Thank you for the attention.
Thank you very much, Tommaso, for the nice presentation. We have a last presentation today. It's about high-dimensional multivariate analysis of compound flooding estuaries, a case study in Santona, Spain. Dina Vanessa, are you here? Yes, I see you. Now the floor is yours. Wait, I can see you, but I cannot hear you.
Now?
Now I can hear you, but you're standing on your head, so...
Yes.
You're upside down.
Why. Let's see if I can fix that. Okay, I don't know what is happening, but let me introduce myself. I'm Dina Gomez. I'm from Colombia, and currently I'm a PhD student at the University of Cantabria in Spain. And I would like to talk about my PhD project, which is related to compound events. And so I can say that in estuaries, interactions between rainwater, river flow, and coastal water levels can increase the risk of flooding. And these separate but physically connected processes can often occur at the same time, not necessarily in extreme conditions, resulting in compound events that can cause big economic, environmental, and social impacts. And what happened? The traditional risk assessment usually looks at one flood factor at a time and do not consider the combined effects, which can lead to misestimations of flood risk. In this regard, while progress has been made in using multiple variables, it is often limited to the bivariate scenario, as dealing with 3 or more becomes more complex and computationally expensive. This work presents a methodological framework for the multivariate characterization of the joint return periods in high dimensions, and particularly a pilot case is employed to analyze the interactions and the dependency structures among 6 different pluvial, fluvial, and coastal flooding drivers in an estuary in northern Spain. The approach relies on the implementation of statistical models and machine learning algorithms to assess the joint return period in the high-dimensional setting. The methodology has the following sequential steps, as we can see in Figure 1. First one is a pre-processing, and here we develop an exploratory analysis of the dependence between the 6 proxy variables. It means exploring the relationship of these variables and assess their dependence and the degree of correlation. And the variables are storm source, wave height and peak period, wind, river discharge, and precipitation. And because not all variables show extreme values in every event we're looking at, we use mixed distribution to find the best fit for the marginals in each variable, as we can see in Figure 2. This makes the framework more flexible, capturing patterns that may arise from multiple underlying processes and consequently improves the representation of the data distributions. The second step is a high-dimensional dependency structures. It means once the dependency between the 6 variables has been assessed, the next step is to correctly represent these relationship structures. Here, using Archimedean and elliptical copulas in binary constructions, the strength and dependency structure among the variables are optimally represented. Pair copula constructions aims to decompose the multivariate dependencies into a set of bivariate copulas to flexibly model the high-dimensional structures, as we can see in Figure number 3. And finally, the last step is the multivariate design events that, using an stochastic event generator, we create synthetic representation of the dynamics. And by considering a specific hazard scenario, in this case, we are considering the Kendall return period, we calculate a critical layer and the multivariate design events. This layer defines the hazardous region, separating the dangerous and non dangerous events. But it's important to highlight that in high dimensions, this layer doesn't have graphical representation, but we can develop the layer in a mathematical way. And Table 1 provides a comparative analysis of the outcomes derived from both the conventional univariate and the multivariate methodology. Specifically, the multidimensional Kendall framework shows smaller design quantiles. However, it's important to be cautious when directly comparing them, because each approach, the univariate or the multivariate, can accurately describe its own sets of events. Comparing them means comparing probabilities related to different failure mechanisms. Instead, these findings emphasize how the chosen estimation method significantly affects the values assigned to design events for a specific return period. This study improves our understanding of compound events involving more than 3 factors, while also reducing computational costs. And finally, considering the interactions of multiple flow drivers is crucial for hazard assessment, infrastructure planning, and emergency preparedness and response. And thank you for listening.
Thank you very much for your talk. So I just have a look into the round. Gaetano, Ariana, I think we are staying with 7 presentations.
No, I think that we are respecting the final program of this session, so we can give space to the questions to all speakers, if you agree.
Yeah.
Yeah.
Good. So we have not made a plan or a schedule how we deal with now with the question and answer round, but I would say, as we are all here working in our field, we don't need to have a clear structure. I think if there are questions, many of them are already answered, and I think the one which are not answered, we can ask from the Q&A at the moment, because there was a question to Joel, you used HEC-RAS. Can HEC-RAS consider all flows you mentioned based on sediment concentration in the flow? I don't see Joel here. No. Joel, are you still in the room?
No, it seems that he's not anymore in the room.
Okay, then I would say we keep that out. Then we jump to the next one. The next question is to Rodiana. How do you digitalize the satellite image? What's the tools you used?
Thank you for the question. The tools that I'm using is Google Earth Pro. I'm using the software itself, and in Google Earth Pro, there is a digitizing tool features that is very, very much helpful for me, and it's good enough for me to do the preliminary study with.
Maybe I can add directly a question there to this question, because when I remember you had 5 years of Google Earth, what you analyzed, where you got it. And I understood that in 2016, it was a debris flow event. So the question was it only 2016 a debris flow event, or were all of these 5 flood events debris flow events?
No, the debris flow event occurred in 2015.
Yeah.
I think it was like by the end of 2015, and the years that I've selected are based on what year that have satellite images. So the closest to the 2015 event is the 2016. That's why I took the 2016. It's
okay.
And the event occurs a few months, but not throughout the 5 years.
Okay. And another question, do you have an idea roughly what are the flood discharges in this area?
No, not yet. I haven't. Honestly, I haven't really studied on that yet.
Okay, thank you very much.
Yeah.
Daniela, you raised your hand.
Yeah. I raised my hand because I have a question directly for her, so I think it is the right time to discuss. My question is, if you consider the time lag that could exist between the time when the satellite image is available and the real extent of the flood, because I don't know if this is the case, but it may happen that you have availability of satellite images after a while, after some hours or days after the occurrence of the flood. And so it may happen that the extension is not the real one. So did you consider that, or how did you consider that?
Yeah, I tried to check whatever it is that is thank you for the question first. So I did try to look for as much as satellite images that are available in the Google Earth. So and there is none that so far I couldn't find one that is closest to when the event is occurring. So that's why I just took whatever it is that is available for me for this preliminary study.
No, my is only a suggestion for your future work. In the sense that it depends on the kind of event that you are considering, and also the extension of the flood. If you have a very slow flood, where the water persists on the terrain for many days or hours, probably this problem is not so relevant. But if you have a very quick event, it may happen that the flood extent that is given by satellite image is strongly underestimated with respect to the real one. So this was only a suggestion and an awareness for properly considering the information that you get from satellite images. That's all. So if you can verify this, I think your work will be more robust. Okay?
Thank you so much for the suggestion. I appreciate it.
Good. Let's continue. Maybe there are more questions to Rostiana at this moment. No? Then I would say let's open the floor again. I will read for the next question in the question and answer. What pixel resolution do you use for Sentinel-1 satellite images? I wrote down some word that said Sentinel-1. So who was using satellite images? No, nobody from Sentinel-1? No? Then I will put the question to the back. Maybe we can answer them later. Okay, I think in the question answer, everything is answered so far, but we can answer. Some questions were answered live, so you can also have a look to the Q&A. And then I would open the floor maybe for more questions from your sides, to all speakers, of course. Maybe then I will continue with a question for Isa, because I was thinking about your 3,126 samples, what you had, where you subdivided then in 70% for the calibration and 30% for the validation. Did I get that correct?
Yeah.
Okay. What I was wondering, or what I'm always wondering is, did you also try to change a little bit the distribution? Let's say using 30% for calibration and 70 for validation, or 50-50. Did you try that, or do you have an experience with that?
For the first step, I used the cross validation, and I categorized my data in 5 different groups: 80 for calibration and 20% for validation. After that, I was found that the result of all of the 5 sections are very close together, and finally, I decided to check the lower percentage of the training sample, because of that the number of all samples is significant. I started with the 50 to 80, and based on the results of training and testing, and we need to model that the difference between training and testing will be the minimal, and I finally tried to select 70 and 30 as the final percentage for calibration and validation.
Mm-hmm. Okay, thank you. Because I was wondering, because always depending on which study you're reading, it's between 50-50 or 80-20. And very often I'm wondering how much is really a good value, or at least if authors of papers did here some cross-check, some cross-validation. And what I was always also wondering, a second thing, you have used HEC-RAS as a model to couple it?
Yeah.
Okay, is it feasible also to use other models, like to easily transfer it if somebody uses his own software, for instance, to implement this way?
The main problem with the AI-based model is when they learn and they can estimate and predict only in the main range that they learn from the training sample. We use the HEC-RAS to generate new sample with more discharge, and it's the first phase of our study. And at the next step, we will use the other hydrological models such as GR4J to compare the performance of different numerical model as well as the final model as the AI-based model.
Mm-hmm. Okay, thank you.
Yeah, thank you.
Are there other questions?
Hi, Stefan. I have some question for Amir, and I think that there is also another question also in the Q&A chat. So maybe I can start, and then we will have the question from Q&A. Okay, I have very lots of questions in reality, but I will start with the first one. My first question, Amir, is how did you choose the informative layer that you have used for the vulnerability assessment? So did you investigate literature? Did you look at the phenomena? Because you only had that available informative layer. So how did you choose them? And the second point is if you validate somehow the results that you got.
Sorry, I didn't get the second question.
The second question is if you validate somehow the results that you got with respect to the vulnerability of the area to suffer flood hazard?
For the first question, there are lots of criteria for the flood mapping. We are studying several literatures, and we create a questionnaire. Actually, the first step of our study was based on the questionnaire, and we asked some experts to fill the questionnaire and tell us which of the criteria is more important in our study. And we use some multi-criteria decision-making models like AHV to weighting criteria and classify the criteria based on the priority.
So basically, it was a sort of a bottom-up approach. So first you asked which were the important information, and then according to the weighting that you got, you identify the informative layer to be included.
Exactly.
Okay. And with respect to validation, did you have the opportunity to validate somehow the results? So, for example, by overlapping them with the flood hazard maps or real events?
We have planned to do for future. We have planned to compare the obtained result by the observed data and to evaluate the accuracy of our results.
Okay, I think there is a question for you in the Q&A. That is, what satellite data have you used in your analysis?
Actually, we use the Sentinel-1 data, but this data was already downscaled, and we use the model builder in the ArcGIS to extract the information of the NetCDF file to use in our study.
Okay, thank you. Stefan, do you want to continue, or do you have a question for someone else?
No, I'm quite happy because now I also know who used the Sentinel-1 data. so now I think the question is answered. What I also one question what I wanted to ask, maybe not only to you, maybe to I saw in a few examples, who is using, by the way, some climate change projections in their studies. So a very general question, because I saw it in your case, because I read somewhere change in land use, climate change. So maybe a random question to all of you. So who is meanwhile also dealing with climate change data sets?
Yeah, I guess this is especially important. For example, I have the same question for Daniel, because when you think about James Sapperty must be operative for many years. So it is more urgent than before now trying to consider climate change projection. So for everybody, but also especially for Daniel, how you deal with this problem in your work, or are you thinking about considering this in your future work?
Yes, in my case, we have not considered yet, but the objective is to consider the climate change. So the next step of our study here is to introduce, because I explained it, my model in natural regime. So the next step is to put the dam to laminate the flood. And when we calibrate there, we have we check there the security of the dam. The next step is to consider the climate change and to consider how it affects to the security of the dam. But we not yet started to do it.
Because I also had this question when I read about your 1,000-year experience or flood event. I also wanted to ask, why did you choose 1,000 years? Is this some regulation, some national regulation, what you need to have a look on?
Yes, and I think I don't remember what we choose especially 1,000 years, but I think yes, for I don't remember, but I think that for our study, the 1,000 year period was necessary. Maybe it's for the something. I think the regulation in Spain. But I don't know it's 1,000, but I don't remember. I really don't remember, but I think it's something like that. So we need to use the 1,000 period.
Okay, good. Because I was wondering, because it's also interesting, like in Germany, we're considering for large reservoir, for instance, 5,000 years meanwhile. And I think within 5,000 years, we're pretty sure that climate change action needs to be considered because it's coming quite fast. But one more question, maybe also for you, a last question, because I'm coming from reservoir sedimentation.
Yeah.
Did you also look only on like the water phase, or did you also consider what could happen if you have reservoir sedimentation, or is this not an issue in the area you're working?
No, in the area that I work in, we have not considered the sedimentation. And so no, I don't know, because we don't consider it. We only consider the rainfall data and nothing else.
Okay.
Thank
you.
I guess that climate change is also a concern for the work that is doing Dina, because when we talk about compound events and the possibility of having flooding from the river and coast at the same time, this is becoming more frequent. So what about your research, Dina? Do you think, is there room for considering climate change? Are you thinking about that, or?
Thank you for your question. I think we in a next step in our work is considering the climate change scenarios because of the implication that it can have in our compound event framework. And also for us, it's quite important the role of citizen science and preparedness and how to improve our adaptation and resilience capacities in that community, thinking about the climate change scenarios in the future.
Maybe I can add here a small question, just on curiosity, because I'm not working in Estra or so on. And you said in the end, like you have a reduced computational costs. So can you tell us how long your model run, for instance? Because I have no idea, but I would be curious to know that.
Yes, we are trying to, our work is trying to find that critical layer that we can have the dangerous and not dangerous events. And it takes 1 day maybe. Because we are improving our methodology with an algorithm using Metropolis hosting optimization process, and that worked pretty well in our framework.
Okay, thank you.
Okay, may I change a little bit the issue of the discussion, if you agree, Stefan?
Yes, go ahead.
Okay, just involve Tommaso, and I think also, let me check the name, sorry, Rosdiana again. So with respect to Tommaso, you were the only one that showed us also the coupling between hydraulic modeling and NEMAD modeling. That, as you know, it is my topic, so a question about that is required. I cannot avoid that because it's my research topic. So my point is, which could be the added value of having dynamic damage models? For example, how the results that you get in terms of the evolution of damage can be used for improving risk management, for example. So, and then which is the difference between what you get with a dynamic model and what you get with a static model, let's say?
Okay. Thank you, Daniela, for the question. So about the first question, which was the importance of coupling the hydrodynamic and the damage model, is that the importance is that have the evolution of both the hydrodynamic and at the same time of the damaging process. That is the real added value. This can be used in many ways. For example, what we are thinking about since we developed this model and we actually are working on is that this kind of model can be used to for the civil protection measures, and so you can individuate the regions in which the damage happen first, and so you can take countermeasures and maybe rescue people, also rescue cattle and everything else. And this is the real added value of coupling the hydrodynamic and the damaging model. So to follow also the damaging dynamics that is not so easy, and for this reason is not so common in literature, because typically damage is computed at the end of the flooding event, but the damaging is a process, and so it evolves in time, and so it's important to study also how it evolves. About the second question, I try to remember, it was the difference in the results between a traditional damage model and the approach we are proposing. And the main difference is, again, that you follow the evolution of the damage, and this is important because damage evolves in time, and time, so the duration of the exposition of a general item to an object is important also for the damagement itself. And so understanding the mutual interaction among time and damaging is important to improve the results, and so to have a more accurate estimation. And for example, one of the novelty is that such a model implicitly account for the duration of the event, while typically, in general, damage model require an estimation of the duration, which is not easy, because maybe in some places water ponds for some hours, in other for many days, and it's not so homogeneous also during the same flooding event.
Okay, thank you. And yeah, also another adding point, well, adding value, in my opinion, is that you can count on the real combination between different other variables. So, for example, velocity and water depth. Usually damage models take into account the maximum value of velocity and water depth in a point, but it is not so obvious that they happen at the same time. So this combination yes. may not happen in reality, and this is another advantage.
Yes,
yeah.
Yes, and also because typically the maximum water depth and the maximum velocity is observed only for a small amount of time, but the flooding event may be of some days, some hours, so also that can influence the final value of the damage.
Yeah. Then my question for Luciana is, because you are looking at a very vulnerable area, in my opinion, because you are talking about an ecotouristic area, so I guess that important damages may happen both from an economic point of view, because it's a touristic area, but also from an environmental point of view, because if you tell me that it's an ecotouristic area, I guess that also environmental heritage is present there. So my question is, if you are also thinking about coupling the hazard assessment with a sort of evaluation of which are the most critical area in terms of risk, in terms of expected impact of the flood on the area, for the safety of people for sure, but also for avoiding to having a huge impact on that specific area, to protect more vulnerable areas.
I'm sorry, I did not catch your question.
Now, if you're also thinking about coupling the hazard model with the damage model, or is something that for your PhD is not...
Yeah, I was, that is where my research is moving forward to actually to identify the flood vulnerability of the Melangkap area, which is next to based on the Panataran River itself.
Okay, thank you.
Good. Are there other questions?
Yeah. Also question from speakers to speakers. I mean, if you want to...
If we don't have questions, while you think, I will ask everyone to turn on their camera and smile. It might help having questions. So that we make a perfect order for the session. So 3, 2, 1. Give me a second, sorry again. 3, 2, 1, smile. Great, thanks.
Good. Otherwise, maybe because we have Daniela here, like the chair of the Flood Risk Management Technical Committee, if you have questions about the committee, then you feel free also to ask, because very often what I experience is when we are like on congresses or like on online things, people don't want to ask to push in the conversation or something like that. So now really I ask you, if there are questions, if you want to know something, just go ahead. Don't be shy. Good. If not, then also feel free to write us an email.
For sure.
Exactly. And if you're not associated to the Flood Risk Management Technical Committee, today it's the time to do so. So just making some advertisement for us. As Daniela also said, we have ongoing initiatives, and we're always looking for people who would like to not only to work for us, but to support us, to give ideas, to work together with. Also like an invitation when we are like having meetings and congresses or so, just to drop in. So as more people we are, as more ideas we can collect, and as more things we can change. And we are at the moment having an initiative about the future of integrated flood risk management. And I think it's really important to get like input from people, because we are a committee. So I would say we are a round of experts. However, sometimes there are things we're not thinking on. So if we get feedback or input from your side, it is very valuable. So please feel free also to write us an email or to get in contact with us.
Yeah, if I may add something, this is a very nice opportunity, because for us it is always difficult to have the vision from a senior researcher and younger researcher, and from researchers or professionals from all over the world. Today, it is very nice to see that we are from all over the world, so we can have also experience from different countries. And this, I think, it is a very big added value of IAHR, of our technical committee, and of the different initiatives that we are launching, to have this global vision and this intragenerational vision, if you want. So please, if you want to be involved, probably we will widespread some information about that in the next weeks. And if you want to be more involved, just write us an email, and Stefan and I will be more than happy to be in contact with you.
Good. So, Gaetano, Jose, Ariana, should we end the session and go for a real coffee, not only a virtual one?
Yeah, I think that is maybe it can be a good idea if there are no others, questions or issues to be discussed together. I don't know which is the opinion of Arianna and Jose.
Just to finish the session, Stefan, Daniela, thank you very much for your support for this Congress. With your help, is not the same. We can do this session, this mentoring part that is more so important for your professional. Thank you very much.
It was our pleasure.
A pleasure. And
Thank
we also
you.
have to thank you because you are the organizers, and I
Yeah.
think you have a lot of work for bringing or for making such a success. And I think this Young Professional Congress is a huge success. We have it for the 4th time now, and it's always a pleasure to be there because I think this is really the spot where you can where young professionals can meet, exchange, and also like discuss with us in this thing. So thank you for all the efforts.
Yeah, I totally agree with Stefan. Thank you very much.
Thank you.
Hello to everybody. Bye-bye.
Bye. Have a nice
Bye-bye.
Thank
time.
you.
Thank you. Bye. Bye-bye.
So the next session will start in 15 minutes. And in the meantime, we can very quietly add all the speakers to the room. See you in 50 minutes.
Thank you. So I invite the speaker of the next session to raise their hand so that we can identify them easily. Hi, Gonzalo.
Hi, Manuel.
Have a good session. I need to go.
Thank you.
Bye.
So please, if you are a speaker in this session, please raise your hand so that we can identify you and promote as panelist. So please, if you are a speaker in this session, please raise your hand. Yes, if you are already panelist, there is no need that you raise your hand. Only if you are still in the attendee list and are not still panelist. Thank you. So again, if there is an attendee who is speaker and it is not yet in the panelist room, please raise your hand. In 1 minute, we will start. So if there are still speakers who are not panelists, please raise your hand. Okay. We should be on. So let's wait just 1 minute because there are still other speakers who are raising their hand. So if the last call, if there are speakers who are not panelists yet, please raise your hand. I see Ravi Ande, who has raised the hand. Okay. So I think that we can start if there are no other speakers in the attendee list. Okay, so we can start. Welcome to this session at the International Association for Hydroenvironment and Research Young Professional Network. This is the 4th International Congress. This is not the last session because there will be another session after this, and I suggest you to follow and attend also the other sessions. This session is the first session on water resources management. Will be caused by me, Emanuele Quaranta, and also by Gonzalo Garcias Alen, who is a researcher at the University of Coruna. The chairs of these sessions are Carlos Galvao and Angelos Alamanos. Carlos Galvao is professor in water resources engineering at the University of Campina Grande, Brazil. He worked on hydrological processes and water management, in particular on semi-arid context. Instead, Dr. Angelos Alamanos is a graduate of Civil Engineering Department of University of Thessaly, Greece, and holds a PhD from the same department on integrating the decision support system for sustainable water resource management. So just a few suggestions for the speakers. So again, if you are speaker and you are not still in the panelist room, please raise your hand. You have maximum 6 minutes to present your poster. We will share your poster, so you don't need to share your screen unless there are some problem. We suggest to stay until the end because the question and answer time will be at the end of the presentation. So at the end of all the presentation, there will be the questions. And if you have any question, please write it in the question and answer system. So now I give the floor to the chairs. Thank you very much.
Thank you, Emmanuel. Thank you, everybody in this room. We have more than 70 participants. That's a great audience. I welcome everybody to this session on water resources management. This is related to our committee of IAHR on the same topic. We can straight proceed to the first presenter. But before it, Angelos, you might want to give your welcome address to the session.
Thank you, Carlos. Well, good to see you again. Welcome, everybody. We're happy to see you and have all these participants. No further thoughts. We can delve into the presentation.
Thank you, Angelos. So let's proceed to the first presentation. Analyzing reservoir sedimentation trends and forecasting the future using Brune's curve. Yes.
A very good afternoon to all of you. Thank you for giving me the opportunity to present in this floor. Hopefully, I'm audible to all of you. Yes, sir. Okay, thank you, sir. Today I'm Shubhasri Sharkar. I'm from Shiksha and Anushandan University from India. I'm presenting my research work on the topic of analyzing the reservoir sedimentation trends and forecasting the future using the Bruns graph. This is a case study of Hirakud Reservoir in Eastern India. We know the soil erosion and the sediment yield from the catchment. These are mostly responsible for supplying the sediment loads that are ultimately related with the significant reduction in the storage capacity as well as the lifespan of the reservoir. So by analyzing the historical sedimentation data, this research endeavors to provide the valuable insights into the projected lifespan of the Hirakud Reservoir, which is one of the most vital infrastructure on the river Mahanadi in Eastern India. And this research mostly it suggests that if this sediment flushing operations or managements, if it is not implemented, then Hirakud Reservoir is on a trajectory to deplete its entire storage capacity by the year of 2110 due to the current sedimentary rate flow. So this continuous forecast underscores the urgency of the adopting the effective sediment management strategies to prolong the reservoir's operational life and safeguard its continued utility, ensuring a sustainable water supply and supporting the vital functions. Therefore, the main objective of this research is to comprehend the projected lifespan of the Hirakud Reservoir and underscore the necessity of robust sediment management for a sustainable water supply. For this, the Bruns trap efficiency method was employed. Trap efficiency, which is one of the most important terms, that is defined as the ratio of the amount of the sediment that is caught by the reservoir to the total inflow of the sediment. So if the annual sediment inflow was multiplied with the trap efficiency, then it is a process to get the value of the annual sediment volume deposited into the reservoir. Hence, the time to fill the different storage zones of the reservoir was obtained after dividing the actual volume of different storage zones by the annual deposited sediment volume. So if this trap efficiency of the Hirakud Reservoir obtained from the Bruns method it is represented in the form of the graph from 1957 to 2110 in the figure 1. And here we can see at the time of the initial time, that means at the time of the impoundment of the reservoir, it is seen that the trap efficiency stood at around 92%. That means it is mostly, it is full of storage. Its storage capacity is at high level. However, over the years, it has exhibited a gradual decline, starting slowly and then accelerating. This projection indicates that by the end of 2100, this trap efficiency is expected to diminish ultimately to zero. In the period up to 2050, there is a minimal variation in the trap efficiency. But beyond 2050, a significant reduction is projected. This is due to the complete failing of the dead storage zones within the reservoir. Not only that, if we are going to compare the all other reservoirs, important reservoirs in India, then it is seen in the figure 2. The figure 2 actually represents a comparative view of trap efficiency trends of 3 reservoirs using the same method. And here it is seen, yes, obviously over the years for Hirakud and Govindasagar reservoirs, it is decreasing over the time, but at different rates. However, in case of the Pong reservoir, it is slightly increasing. Because of what? Because of largely due to the substantial reduction in the incoming sediment because of the construction of some check dam at the upstream side at the Pandu. So that's why the draft efficiency is going to be increased for the case of the Pong reservoir in comparison to the other reservoirs. Here, therefore, we can say if we are going to utilize the Brown method, we can get an idea at what time the reservoir will get completely filled up if we are not going to take any management process or any reservoir sedimentation any reduction of the reservoir sedimentation. It experiences that a sharp decline is there due to the accumulation of silt after the 2050, because at that time already dead storage zones of the reservoir is going to be completely silted. However, above this zone, that means above this dead storage zone, there are live storage zone is there, cross storage zone is there, where there is a variation in the sediment deposition patterns emerge primarily because of what? Because of the fluctuation in the rate of the sediment inflow and the trap efficiency. Projections indicate that without the regular flushing operation, or if we are not going to take any catchment treatment, then the gross storage zone of the Hirakud reservoir will completely depleted after, we can say, by the end of 2100. That means the bed level will going to rise to a level of 192 meters, which is the highest level of the reservoir. So that's why it is said that means to mitigate the rate of the sedimentation into the Hirakud reservoir, it is important to implement some improved water management practices alongside some sediment management techniques. And we can say, looking ahead, some future research avenues could also explore taking some additional strategies to confront the ongoing challenges of sedimentation in the reservoirs. So thank you all for your kind attention and engagement. And same time, I also want to say thanks to all the collaborators and the institution that contributed significantly to the research endeavor. Thank you very much.
Thank you for your interesting presentation. It's we can have good discussions in the coffee break time. Thank you. So let's proceed to the next presenter, please. The title of the presentation is Evaluating. Okay, it's on the screen. Thank you.
Hello, sir. Am I audible?
Yes.
Thank you, sir. Warm greetings to one and all present here. Myself, Megha Raj, and I'm here to give a basic idea on our study on evaluating the geospatial variability of sedimentary and hydrodynamic factors in the Ashtamari estuary. Our study basically describes about the sedimentary variability in Ashtamari estuary. Furthermore, the lateral as well as longitudinal variation of hydrodynamic factors, basically salinity and turbidity, were also evaluated in the Ashtamari estuary. Now, as far as sedimentary analysis was concerned, 8 sets of soil samples were collected from about 8 sampling stations from distinct sedimentary environment in the Ashtamari estuary from 0 to 25 kilometers using a conventional grab sampler. Now, dry sieve analysis, wet sieve analysis, and hydrometer analysis were conducted to assess the soil structure and particle size distribution. A secondary field visit was also conducted during the pre-monsoon period to enumerate the hydrodynamic factors, and for that the samples were collected in the secondary field visit were analyzed using various laboratory techniques. Now, moving on to our results, the study basically identified 5 soil types: cobbles, gravel, sand, silt, and clay in the Ashtamari estuary. Notably, the estuarian mouth exhibited the highest clay content, while in subsequent stations towards the riverine head, coarser particles became dominant, indicating gradual decrease in the clay content. This sedimentary variation in the estuarian bed is clearly spotted in figure number 2. Now, moving on to the hydrodynamic factors in the estuary, we basically conducted a study on salinity and turbidity, and we noted that salinity increased with depth at a given location and decreased with increase in distance from the estuarian mouth. The increase in salinity with depth at a given location indicates strong salinity stratification in the estuary, and the decrease in salinity with increase in distance from the estuarian mouth is basically due to the increased rock formations that act as a potential barriers in upstream of the estuary. Now, unlike salinity, turbidity showed an increase both in lateral as well as longitudinal direction. The increase in turbidity with depth is basically due to sedimentary suspension at the bottom, and the increase in salinity near the estuarian head basically caused the decrease in turbidity in the longitudinal direction. So these basically constitute our results. Now, as a conclusion, we also classified the estuary basically into 4 zones: well mixed brackish zone, partially mixed zone, salt wet zone, and freshwater zone. From the estuarian mouth to about nearly 20 kilometers, we observed nearly constant high salinity values along the vertical profile. And from about 21 to 25 kilometers from the estuarian mouth, partially mixed zone was found. And from 27 to 30 kilometers from estuarian mouth, most stratified or about least mixed part of the estuary was observed. And the freshwater zone was observed from 33 kilometers from the estuarian mouth. So this is all about our study. Thank you. Have a great day ahead.
Thanks very much. Another interesting presentation on sediment dynamics, this time on coastal area. So a good information for the discussion during the coffee break. Thanks very much. Let's proceed to the next presenter, please.
Hello, sir. Am I audible?
Yes.
A very fine good evening to everyone. I'm Bima Musafna Aman, finally a BTech Civil Engineering student from TKM College of Engineering, Kollam, India. I'm here representing my team to present on the extended abstract of a topic, Influence of COVID-19 on the plastic debris accumulation in Ashtamudi Estuary. Now let us move on to the introduction. Ashtamudi, the second largest wetland ecosystem, has been found designated as a Ramsar site, is of great environmental and economical importance. But the continuous disposal of waste, including plastic debris, had indeed led to the degradation of the water quality there, and which is severely affecting the ecosystem services and functions. Although the government had initiated many policies, there is still lack of efficient waste control and management systems. So this study was mainly conducted in order to understand the influence of COVID-19 on plastic pollution in Ashtamudi Estuary by analyzing the trend of usage and disposal of plastic among local residents. Moving on to a methodology. A questionnaire survey was conducted among 100 residents over a period of 2 weeks, generating 80 responses. And the questionnaire survey mainly consisted of 17 questions that pertains to the type of plastic usages, method of disposal, frequency of disposal during pre-COVID, COVID, and post-COVID scenarios. Now, moving on to the results of a study. It was observed that, as we can see from figure 2A, it was observed that the use of the refilling of sanitizer bottles was seen more during the COVID time as compared to the pre-COVID situations. And also a similar trend was seen in the case of plastic bags, which showed a decline in its use during the COVID-19 situation as compared to the pre-COVID situation, and in the post-COVID situation, it remained almost the same. And also the use of packaged milk instead of reusable containers also increased during the COVID-19 scenario in order to ensure the safety from this against this spread of virus. And also, we can see from figure C that that the dependence or the preference of online shopping also had increased during the COVID-19 scenario and post-COVID situations. And from the results, it was evident that nearly 94%, that is, the most of the people had adopted an inappropriate way of waste disposal, which predominantly consisted of burning, dumping, and burying. And also 91% of them had already agreed that there was were aware of the pollution at Ashtamudi estuary. 65% of them had reported it to be a severe condition. So moving on to the conclusion, the increase in plastic pollution during the COVID condition did not affect the estuary as such, because due to the restrictions imposed by the lockdown, because it prevented the people from dumping the waste directly at the site. So this was an initial step towards a future work of developing a spectral index that is more specific for plastic debris detection at Ashtamudi estuary, utilizing remote sensing and geographic information system. With this, I would like to conclude the presentation. Thank you, everyone, and I wish everybody a good day ahead.
Many thanks. Very, very interesting study with collection of data. Very interesting data and not usual. So very good for our discussion in the coffee break. Thank you. So we can proceed to the next one, please.
Yeah, so that's my turn to talk briefly about a short paper on a topical issue. This was exemplified by years changes in Greece's water governance. So to give briefly some background information, this March, the Greek government included water management along waste and solid waste and regulatory authorities. It's a body of around 10 employees in total. And this triggered many protests and claims for a potential water privatization planned by this neoliberal government. So this paper briefly examines some literature examples to see the potential motives leading decisions, the consequences of water privatization in Greece, drawing lessons from this sort of municipalization. So the outcomes show that this situation started during the 90s, where services were privatized in Latin America, countries like Argentina, South Africa, and driven by international parties like they often as conditions for loans. So similar moves were seen after the 2000 crisis, global north, including the UK, Paris, some in Canada, and of course the Mediterranean. And the one side of the literature, there is one body of papers that are in favor of privatization, arguing that technological outcome, efficiency, and the market and things like that. While the critics, another way is that this can be done also under the state's rule. Otherwise, there are worries that social and private water control, along with concerns on equity and the ability of the access to water resources, and the motives were the profit it might be set for the public and without control. And in reality, the literature shows that these issues have been more often the case. Thus, many countries have municipalized their water services during the 0s and 2010s. And so in this case, in Greece, there is a Ministry of Environment having the role of setting the general guidelines, such as the river basin management plans. And then there are the local authorities who are responsible for the implementation of these measures. The biggest issue as it identified in the literature is that they do not communicate, so there are gaps in communication. They both are understaffed and underfunded. So there's also an issue of skills and capacity. So often the European money that comes to the state that can be used for works, they are not getting used. So they are not being absorbed, thus returning back to the European Union. And we had in our team here project which finished last year, which is a living lab on water management with all Greek stakeholders, and the representatives of the representatives were preparing at the time, and they showed the idea of an independent authority, like a one-stop shop for management. And overall, there was a consensus of the participants of the living lab to support this idea. But as long as the reform of the water management in the country had at its core the irrigation water management, simply because it's the largest pressure and the largest consumer country. However, the bill as it came, and we reviewed it here, it's mostly about urban water services. It's focusing on the financial management of the urban water suppliers. And with respect to the irrigation water, it's treated as an addition to the energy and the solid waste authorities, which are already understaffed. And the agricultural water providers, it's included in the bill, but after the Article 1235, the irrigation water providers are excluded from the evaluation of business plans, and also for the data collection regarding the techno-economic details of the provision of water services, and also excluded from the provision of a 5-year general water services plan. So that's how the concerns for water privatization were spread. And at the time, the government assured that there will be no privatization for now, but in parallel, it's crucial to show that this new authority is independent. So this means that it will be its own decision whether water will be private. So this is crucial because it takes away the political costs of the government, of any government. There's now one place. And the international experience and the lessons that we can draw from this case is that in the case of privatization or other forms, like public and private partnerships, the outcomes more often they depend on the regulatory control, the objective accountability structures, and the ability of the state to properly supervise the private actors, so to ensure that they will not act at the expense of public goods. So currently these 2 points are not in place, and because there's no adequate resources in the authority. So it seems that public ownership will persist, the potential for third-party involvement or public-private partnerships. And with respect to the ability of the ministry to maintain accountability and supervise the private actors, this has been proven weak because there is a continuous degradation of the country. So it's in concluding an important point and a recommendation of this work is that if this time comes about privatization, it's crucial to build a capacity within the public authorities, and like building an in-house capacity in the ministry and the regional authorities, in order to don't leave the situation completely up to the private actors' quality and motives if they take over. So it's regardless of the form of ownership, but it's necessary to build more capacity and have more trained staff and a continuous regulatory operation. So that was that. Thank you very much.
Thank you. Let's proceed to the next one, please.
For the next one, we don't have Dan here, but she sent us a video, so wait.
Emmanuel, we cannot listen.
Yeah. Do you listen the video?
No, we cannot hear the sound.
Ah, no, really? I was sorry. Uh, but I don't know how to change it.
Okay, try to.
Okay.
No.
Not now.
No.
No. Now.
No.
No.
We can see your poster. You can present as it is.
Gonzalo, I can hear you. Yes, I can hear you.
Exactly, but can you hear the video? The voice in the video?
No. No. But you can. There is a button when in the dot at the bottom of the screen with the dots. Do you see the dots? Share sound.
Ah, okay. Here.
I'm from the University
Now?
of Florida.
Perfect.
Yes.
Hello, everyone. It's a great honor for me to attend this meeting. My name is Dan. I'm from the University of Florida. I'm so sorry due to my personal reasons, I couldn't meet you in this meeting. So I made this video to show our work on the assessment of water sustainability in Northwest China. As we all know, over the past decades, Northwest China has experienced rapid socio-economic development, further stressing its freshwater quantity and quality. However, there is little knowledge of the long-term status of water resources and the anthropogenic impacts, both negative and positive, in this spatial area. In this work, we present a holistic spatial temporal assessment of Northwest China's water quantity, quality, and water scarcity based on water use intensity, water scarcity index, and statistical trend analysis and tests combining multiple data sets spanning the past 2 decades. Our results showed that the water use in northwest China has significantly increased by 10% because of the region's expansion, even though water use efficiency has improved. Surface water extraction provides the majority of northwest China's water supply. Compared to water quality, water shortage due to high water use and the high water stress index are both clearly the most severe issue in northwest China over the past 2 decades. There is still significant water scarcity, especially in Xinjiang, Ningxia, and Gansu, the driest area of China. There are inequalities in water availability for water use among provinces. This may give more water supplies. The limited water supply do not meet the current development. This study reveals that northwest China's water scarcity has not been alleviated. Northwest China still needs more diverse and flexible regional water management strategies to cope with its severe water shortage problem. To solve this, we think both water supply and demand management should be enhanced, such as BMPs. Balancing water availability and demand will be crucial to achieve truly sustainable development in northwest China.
Thank you. Interesting paper as well. Let's please proceed to the next speaker.
Good evening, everyone. My name is Haris, and I'm doing my PhD at IAHR Delft Institute for Water Education, located in the Netherlands and the Technical University of Delft. Today, I will be talking about the infiltration ponds as their potential to act as a managed aquifer recharge in order to address the water stress ratio. And particularly, I will be focused on the low land mesoscale catchments, such as the area which is in the Netherlands. So the area of the focus of this study is a transboundary catchment, and it is located between the Belgium and the Netherlands. It's equally distributed between these two countries. And in the recent area, this area is experiencing the water drought situation only in the summer months. Majorly in the June, July, and August months, and then the main land use used in the area is in agriculture. And in the recent years, they are facing this water stress issue there, and the major area is rain-fed, which is then seeping into the river and then flowing towards the sea in there. In order to see the potential of the aquifers, we have developed a hydrological model, which is a fully distributed model, had an hydrologic component and a hydraulic component, and then also a groundwater component in this. And then this is the Mike Shee and Mike 11 integrated models. In the figure 2, you can see the conceptual design of this model. We have used the local data and then the global data sets, which are being complemented by the local data sets in order to set up the model for the 10 years. And then this area is quite big, so we cannot provide the infiltration ponds everywhere. So we did the initial preliminary methodology with this, and then we were looking into the 2 factors. The first one was the hydraulic conductivity, and then the second one was the groundwater level. So we were looking into the hydraulic conductivity, where the hydraulic conductivity is high, so the water can seep very fast into the ground. And then the other condition was like the groundwater level should already be lower in that region, so the potential head difference will be higher, so the water can actually percolate into the storage reservoir, a groundwater storage reservoir. So we identified this area, which is highlighted in gray in the figure 1. So still it is quite big, this area. And then when we are running this model in with this setup, we look into the whole water table, and we were looking into the discharges into the river. We were looking into the saturated zone storage and the groundwater levels. And then these infiltration ponds have a capacity to increase the average water table by the 1 meter during the winters and ½ meter during the summers. And we found that the saturated storage capacity has been increased by 9%, and also the base flow contribution towards the river is also increased by 9%. And if we look into the flow duration curve, which is in the figure 4, then we can identify the flow in the river has been increased in the low flows and in the mid flows. From this figure, we can interpret like during the high seasons, the water is being high flow season, the water is being stored into the groundwater, and then slowly distributing this water to the contributing this water to the river. So the groundwater storage is acting as a natural storage area in order to address the situation in this model. So from this study, we have found that indeed the infiltration ponds can contribute towards the groundwater recharge, but the rate of this recharge is not uniform. At some locations it's high and at some locations it's low. And then in the next step, we will be discussing our results with the stakeholder there, and then showing our spatially distributed map with the authorities there, and then maybe these maps can act a guide for them in order to see their necessity where they want the water tables to be high, and then this map can be serve as an initial survey for them. And then based on in talk with them, we can refine our spatially distribution and then see like what will be the annual contribution towards the groundwater and how this infiltration ponds can contribute to solving this problem of the water stress in that area. Thank you. That was all from my side.
Thanks a lot. Also a very interesting article. We can generate a lot of discussion in the coffee break. So now please let's proceed to the next one.
Ladies and gentlemen, am I audible? My name is Kubisa Onembokwe from Botswana, but currently staying in Tlemcen, Algeria as a student of Masters of Engineering. I am here to present about the application of firelight scoria as an adsorbent for the attenuation of toxic divalent ion of a copper from industrial wastewater, mainly looking at the batch adsorption, kinetics, and reusability studies. There has been an upsurge in the discharge of effluents from industries. Such effluents are laden with toxic heavy metals, including copper, which can be harmful to human life as well as the environment. Therefore, there is the need to remove such toxic metals before the discharge into the environment. Here, our aim is to investigate the effectiveness of firelight scoria or the copper smelter slag as an adsorbent for the removal of copper ion from a wastewater. Our methodology, the adsorbent, which is the firelight scoria, was collected or sampled from the mine, which is BCL mine in Botswana. The media was washed with distilled water to remove impurities, dried, ground, and was characterized using XRD, XRF, SEM to know the physical and chemical properties of such a media. The preparation of a synthetic water using cupric sulfate 3.09 gram salt was used to prepare stock solutions, and the concentration, the initial concentration of the samples which were used was 200 parts per million copper to mimic the industrial wastewater chemistry. The batch experimental studies were done to investigate the physiochemical parameters, their influence in the absorption of copper. Regeneration study was also conducted using 0.1 molars of sodium hydroxide as an eluent to restore the absorption capacity of spent firelight scoria media. In our results, figure number 1.0 shows the contact time effect on the absorption of heavy metals. It was found out that the maximum absorption capacity was attained after 15 minutes. And also, when you look at the figure number 2.0, the absorption regeneration studies or reusability studies, it has been indicated that the percentage recovery of the adsorbent was dropping due to the destruction of active sites in the media or the destruction by temperature. Moreover, chemioabsorption was solely the absorption process. Pseudo-second order kinetic model was best described by the absorption process as shown in a table 1.0 with R squared a value of 0.995. In conclusion, ladies and gentlemen, we may sum up by saying firelight scoria as an adsorbent can be used to reduce toxic heavy metals, including copper from industrial wastewater. Considering the availability of such a media in large quantities in Botswana, its cost effectiveness and promising retention capacity, it can be applied as a low-cost adsorbent to remove copper from industrial wastewater before the discharge into the environments. Moreover, it is recommended that further studies may be done by modifying the adsorbent and also the batch. Also, the column absorption studies will be done to study the practical implications of such a media. Thank you, ladies and gentlemen. That's all.
Thanks very much for the interesting presentation. And let's proceed to the next speaker.
Is the speaker present or not?
Mohammad? I think it's not here.
So let's proceed to the next one, please.
I'm checking, but no, it's not in the panelists.
Hello, everyone. Can you hear me?
Yes.
Thank you. My name is Lav Kumar. I'm a PhD student in the University of Florida. So I'm presenting this research on behalf of my first author. He's busy. So the topic of this presentation is quantifying the groundwater potential and the quality using GIS, electrical resistivity, and the well data from the Tharparkar. So Tharparkar is a desert area that is located in the Pakistan, and it is the region like the population is mainly dependent on the groundwater. So women have to travel, like they have to walk 5 kilometers, like 5 hours a day to feed the water. And then the water of that area is not like usable, that is brackish, saline, and it is not potable water to use. So in this research, we have used the electrical resistivity along with the GIS, and we collected the groundwater depth from the different wells across the Tharparkar area. So across like 120 location, we got the depth data as well as the vertical electrical sounding data, the VES data, using the electrical resistivity. So the resistivity range from the 75 ohm meter to 250 ohm meter, which is like aquifer quality. We can find fresh water, either is it saline or is it the brackish water. The You can see in the figure 1 that describes the water column depth all around the 827 open dug wells that are there, like that are open for the public to get the water from those wells. And the weather of that area is not like suitable, like it's not like we get a lot rain out there to store the water or to irrigate the water. That's the only um the open dug wells, yeah, or the groundwater is only the source for the drinking water and water for other uses. So the average depth we found was the 1.14 meter, but you can only see the one well that was like around 10 meter. The other wells are below the 3 and 4 meters. With the results, the layer-wise minimum and maximum achieved through resistivity values of the subsurface material and the resistivity range. So we determined the true resistivity minimum was 16.13 to maximum 335. So that is like loose and surface sand. And then we have second layer is a semi-consolidated sand. Sorry. And the third one is consolidated sand. And then fourth layer was the silt and clay. In the maps of the figure 2, you can see the depth as well as the water quality of that area. The study evaluated the resistivity values, indicating that predominantly dry condition. So the most of the wells were the dry, and the first layer and second layer was like ranging from 0.04146 to 17.52 meter, and the layer 3 and 4 varied with the thickness 3.26 to 86.66 meter. So the correlation with bore logs and the well data confirmed that the groundwater potential is some areas within these layers, like the first, second, and third layer. But using the calculated area from the figure 2 based on the table N1, so we multiplied the average depth with the water column in the well that can be shown in a figure 1, the groundwater potential qualifier. So the presence of water was evidenced by the consolidated sand, silt, plus clay layer, and with varying water potential that you can see in a figure 2C and 2D. The conclusion, the research established a comprehensive 4 geoelectrical layers arrangement encompassing varies from loose sand, surface sand, semi-consolidated sand, and consolidated sand, and silt. plus clay layer, determining that the groundwater potential to be around like 105,064 and 13,822 cubic kilometers by analyzing geoelectrical data. But the water quality of that area was not suitable. Like we have not found a good water quality all around the wells. Some of the wells was the saline and was not good for the use of drinking purposes because it has high TDS and as well as the electrical conductivity. This is all about my presentation. Thank you.
Thank you. Very interesting presentation and interesting data. A lot of wells.
Thanks.
Let's proceed to the last speaker before the coffee break discussion.
Hello. We're actually doing a bit of a group presentation in this short time today. I'm Freya from ARUP and I worked on the Wash Basins Toolkit, which we're presenting on today. The Wash Basins Toolkit was developed collaboratively by ARUP and Frank Water to address integrated water resource management issues, specifically for an Indian context. And after successful trials in India, the Wash Basins Toolkit and the supporting Android app was updated for use in global context. So this year we collaborated with NGO AMRA, who are doing work in Africa, to trial the Global Wash Basins Toolkit in Kajiado County, which is a semi-arid region in Kenya with a sparse population, and it also includes a lot of the population who are nomadic. And the trial was carried out in 2 catchments within Kajiado, Morgo and Kippa. And this trial was also reviewed independently by a master's student from the University of Bristol. That's just a little introduction to the project, and we're going to hear a bit more about from the background of the toolkit from my colleague from ARUP, Zach.
Yeah, thanks, Freya. Hopefully you can all hear me. So as Freya mentioned, we as the sort of Wash Basins team set out to produce a scale and geography independent toolkit. So this was a toolkit that would guide through to producing a water security plan at WSP that is aligned with IWRM principles and which seeks to balance social, economic and environmental demands and impacts on water resources in a sustainable and equitable manner. We wanted this toolkit to be a complete guide to the WSP process and define what a WSP is and should cover. But further than that, we wanted our toolkit to provide tools for data collection and crucially to set out a standardized method to achieve that scale and geographic independence that I mentioned. We did this by breaking down the WSP into 6 simple stages. So our 6-stage process can start with a needs assessment, but really starts in earnest with a reconnaissance visit. This is an initial site visit to really understand the key sort of site parameters and site context. Stage 2 is an interim report, looking at the technical parameters, the hydrology, the hydrogeology, as well as the catchment and the watershed context. Stage 3 involves an extensive quantitative and qualitative data collection process for stages 4 and 5, where we begin a period of thorough sort of data analysis of the hydrological, hydrogeological parameters and establish a full water balance for the watershed in question. So finally, stage 6, using the analysis, the reporting and the data collection we've done to date, it's where we produce a detailed WSP with a wash delivery and a water resource monitoring plan. I suppose then most crucially, the stage after this is implementation, and that follows that figure 1 on screen. Judy will now go on to discuss the results from the WSP and then concurrent evaluation. Thanks.
Thank you, Zach. I hope I'm audible.
Yeah.
So from the trial that was conducted in Kajiado County in Kenya, we were able to develop a WSP for the 2 locations that we conducted the study in. So just to note, the locations that were selected are very sparsely populated with an average population density of about 32 persons per square kilometer, which is quite low compared to our national average of about 97 persons per square kilometer. So the inhabitants of the 2 locations are majorly pastoralists who practice livestock farming. And just to emphasize, the livestock population is about 8 times the human population. So the current population is about 10,000 people with an estimated annual population growth of about 5.5%. So from the WSP developed, we were able to determine the location's water demands versus the available water, looking at the various water uses, which is domestic, institutional, livestock, and irrigation. And we were also able to make the projections for the same area up to the year 2044. So in the figure that you see, figure 2.2, we're able to see that there's currently a deficit of about 550 cubic meters per day. And if the situation is not remedied, the region could experience a deficit of about 2,400 cubic meters per day, which is quite high, and that is in the year 2044. So the deficits are even likely to get worse due to factors such as population growth, both human population and of course the livestock population, climate change, poor water management practices that lead to leakages and wastages, as well as environmental degradation. So the current deficit requires an investment of about $820,000, which can be remedied through construction of boreholes, earth dams, and pipeline extensions from the existing water points. Again, if not remedied, the future deficits could require investments of up to 2.7 million, as you can see in the graph. So that's a quick overview of the results. So based on our experience in using the tool in Kajiado County in Kenya, we're able to see that we were able to standardize methods for water resource management, promote information and practices within communities. The application that we used, which is user-friendly, is accessible and helpful, but requires a few adjustments just to better represent local context. There's also a need to have specific guidance on the specific surveys to be used during data collection. There's also a need to improve the accessibility of the tool, add a few reading packs just to make sure that the people interacting with the tool are able to get more information in a faster manner. There was also a recommendation to integrate gender considerations while collecting data, as water is also something that can be gendered with water factors affecting mostly women. We also found it important to align the toolkit with the locally appropriate unit of reference or scale to ensure that field surveys provide a full picture of the targeted communities. Well, that was our presentation. Thank you very much.
Thank you very much. We are perfectly on time. So I would like to know if the presentation by Sakur, Haloshe, and Denavi, any of these, whether they are present here, and if they wish to present their paper, or if they are still missing. Can you help me, Emmanuel and Gonzalo?
Yeah, at the moment, the missing speaker is not raising the hand, so I suppose he's not here.
Okay.
So we can proceed with the questions.
Yeah, we are. Thank you. We already have a question here by Gubash.
Excuse me, Carlos, because
yes.
he's in the session, but I don't know if he's present or not. I'm going to promote him to be a panelist.
Hello. Good evening from Manila. It's too late here. Sorry, guys.
Please proceed. Yes. Thank you.
Yep. All right. Thank you. Thanks for the opportunity. So, yeah, my study is integrated water and sanitation safety planning for small communities. The study was conducted in Jordan, and the tools that were used are actually the World Health Organization tools. Those are the water sanitation, water safety planning and sanitation safety planning, but in an integrated manner. And that was designed for small communities, which is very desirable since the water and sanitation systems are interlinked, very interlinked. So the methods that were actually used were household survey, and they just to note that the study was finalized in late 2022. The methods were used were household surveys and also key informant interviews, and that's it was used as problem-centered interviews, and well, actually the who conducted the risk assessment for the water system and sanitation system were those stakeholders that are engaged in managing bath systems. They were asked and also participated in the field investigations to conduct a risk assessment using a semi-quantitative risk assessment. So we developed an integrated way or approach of those combined WHO tools, water and sanitation safety planning. And just to mention that those tools or this tool was first developed or first piloted in India in a small community, and also after that in Serbia by UBA, Umweltbundesamt, and also the RIVM, the National Water and Environment Center in the Netherlands. So the study resulted in 19 and pointed out some of the very critical risks in the community that was studied. So it resulted in 19 hazardous events, and one of them was very critical, mentioning it, which is cross connection of water and sanitation or water and sewer network. So in the also in the context of limited resources, it was agreed by the stakeholders that having or piloting or implementing this approach an integrated manner is very critical and desirable. And some of the conclusions were that the financial institutional challenges were the impeding factor of implementing the improvement plan, but they are currently working on it and seeking some funds from donors. And it's always about the communication. So a communication gap was very vivid in the between the stakeholders when the wastewater system and water system was first constructed and planned. So additional work, of course, still required to further studying the water pressure and the internal sewer network to find a common ground between the stakeholders on implementing the remedial actions. So this is basically the study, yeah, we're also looking forward at WHO level to piloted it in small communities, other small communities. Over, back to you.
Thank you. So this is the last presentation, and we can proceed to the coffee break discussion session. So we have in the chat a question to Haris from Gubash. So,
yeah, thank you for the question, Gubash. Do I need to repeat it because it's not in a question and answer sessions? So I'm not sure like the participants can see this one or not. So the question of Gubash is like when I was showing the infiltration bounds, and then he's asking like what is the criteria for the identification of the location of this region, the infiltration regions, and then the other question is like when I'm comparing the total area where the infiltration bounds are being provided, and if I comparing it with the significance of the groundwater level rise, is it a good correspondence considering the area or not? And then the third part is related to the autumn season and what is contributing to the higher groundwater levels in that area. So I will be coming towards the first part. So while identifying these locations for the infiltration areas, we were looking into the two criterias. First one was the already present groundwater level, and it was the average of the 10 years from 2010 to 2019, and we were looking into the areas where the groundwater level is already high and the areas where the groundwater level is comparatively low. So where the groundwater level is comparatively low, these were the critical such areas for us. So we identify these locations as a potential area where the infiltration spout can be provided. And the areas where the groundwater level is already high, we were thinking like maybe these area can act as a retention pond instead of the infiltration pond. And the second criteria is like we are using the rainwater harvesting system here. We are not feeding this area from the river or other secondary sources of the water. So we were more interested into checking what is the hydraulic conductivity in the top layer of the soil there. So where the hydraulic conductivity is higher, we were interested in those areas that they can percolate the water very efficiently into these areas. And when we combine the groundwater level and then these the hydraulic conductivities, these were the potential locations which I showed you during my presentation. So in the first part, we defined the infiltration ponds over all of this area, because this is like a preliminary method that we applied, but we were not sure like what will be the interaction of the surface water with the groundwater and how the model will be behave when we were going to provide on this one. And then it was quite interesting, like the recharge is not uniform throughout each cell of the model. It is quite different in there. And then in the end, when we will be discussing with the stakeholders, we will be looking into the what is the land available there or not available? What are the other limitations of the land there? And like maybe we can combine these areas with another land use type, maybe as a grass there or other land use type there. And then we can limit our areas where the groundwater infiltration is the maximum. And then I will come in towards the third part, where the autumn is the most critical one in observing the water trends, highest groundwater level there. Maybe it is because of the reason during the summer, the groundwater table due to the infiltration ponds is already high. And now when the rains are starting in an autumn, so already the groundwater level is high. And then the difference with respect to the base period or the model without the infiltration pond is comparatively greater, because now in the summer, the groundwater level is already been higher as compared to no scenario where there is no infiltration ponds there. So in this month, due to the slow response of the groundwater table, we are having a more positive effect in the season of autumn there as compared to the winter, because in the winter, in the normal situation, the water is already high, and then due to the infiltration ponds, there is no much percolation, and then it is not too much difference in the winters. But when we are comparing the base period with the model with the infiltration ponds, then during the autumn it's more observable the trend is. I hope I was clear in order to communicate the answers.
Yes, for sure. Well, in the question and answer panel, we have already another question by Gubash that was, I think, already answered by Love Kumar. And so we are open to new questions or comments. Angelus, would you like to
Yeah, thank you.
provide any comment to our presenters?
Yeah, all of the presentations were very good. And I had a question. I was wondering with one of the last presentations, the one with the wash basins toolkit, the one that had many presenters, which by the way was good and interesting to see many people presenting. I was wondering about the target audience, if it's being used or is it the communities, is the authorities, where is it targeted and if it's being used?
So the target is just for anyone who wants any WASH practitioner. So it's at the moment been used by NGOs, some in India and then GD's AMREF team. But we want it to be a standardized approach, so anyone, communities have the, it empowers communities to be able to undertake these analysis themselves. That's the aim of it. So it's supposed to be an open source document that just anyone can use. But yeah, it's aimed at WASH practitioners. But I think depending on the context, governments will be more likely to use them. And I think in Kenya, that was a link. Judy might be able to speak to that more because I'm not an expert on the government structure there. But I think that's something that we would definitely look into in the future. But we haven't yet.
I mean, if there are the necessary regulatory frameworks in place to adopt it, that would be challenging. Congratulations on that. It's interesting work. Best of luck with making these things implemented.
Thank you, Andrew. I don't know if Judy or Zach, you had anything to add to that?
No, I don't know. Yeah, Judy, if you had anything on the context, go on. Sorry.
Oh, yeah, thanks, Freya. So for the pilot, we implemented it as a health NGO, where we piloted it in a very small area. But going forward, we envision a situation where this is led by local governments. So the context in Kenya is we have the national governments and then we have local county governments. So we see a situation where counties take this up and roll it out through the existing community structures. Thank you.
Good, an interesting feature of this session was a great number of presentations related to community level water management. That's very interesting, very good that our universities and other research centers are focusing on such targets that are mostly in need of our attention. So it's a very good sign of people-centered research and application. Any other questions or comments from, please feel free to open your mics and comment and talk about each other presentations and research.
Maybe I can add here or ask a question. It was related to the presentation, which was on the data collection during the COVID pandemic regarding the wastage in the rivers. So it was quite interesting to look at that one. And then, and I want to know, like, what is the end objective of that study after this data collection, like what they want to achieve it, like how how they managed to control this in the river.
Yes, sir. Am I audible?
Yes, you are.
So is it related to the COVID influence of COVID-19 on plastic debris accumulation on Astomodi estuary? So actually, we want like our research is actually like we wanted to develop a plastic index, that is a spectral index which is more specific for identifying the plastic, that's truly regarding remote sensing and geographic information system. So here actually we have started the research. This is just the beginning of our research. So we have started with understanding the nature of like how that is how the plastic consumption is there over there. So the severity of the issue. So we are as an initial step, we are trying to understand the severity of the issue there. So later actually if we can develop a plastic index or an index which is more specific, so it will be helpful for understanding or detecting the helping the waste strategies, because it helps us to understand where plastics are present, like inaccessible areas it can be used. So also that is past data analysis can be performed using past satellite data, etc. So that is how we're trying to that's why our main aim is to develop a spectral index. So this is a initial aim for it, like initial step for that. Hope I've answered the question.
Yes, yes, it's quite understandable now. So after once, maybe I will just to clear my head. Maybe once you have this one, and then you can maybe we can control the plastic waste from the source, like you mentioned in the COVID, like what was the concentration, more concentrated wastage, and then from the source we can do something in order to control that source.
Yes, we can actually we can do the debris tracking, source identification, etc. will be possible for us when we are using remote sensing, like than going for conventional methods like trawls and containment booms, which is more labor intensive.
Okay, yeah, thank you. I was interested because we were also looking into the structures which can be provided in a river to control the pollution. It is something going on in our research institute, so I was more interested in asking that. Thank you for adding it to it. Thank you.
Thank you so much.
Thank you. I would have a question for Mohammad Sakur. Your second conclusion is on the communication gap. Could you talk a bit more about that? Maybe he has left. Yeah. Okay. Anyway, would you have we have time for one more question. Okay, since we don't have another question, I would like to say thank you for all of you. I think we had a very diverse and interesting set of presentations. And we can now, I would like to invite you to check the IAHR website, where you can find all the committees and other working groups. And they are very interesting spaces for engagement in our association. And then we can have a brief break until the start of next session that will be in the same topic, water resources management, in about 5 minutes. Thanks very much, everybody.
Thank you. I also invite the speaker to turn on the monitor for the final picture. So, okay, we are on. A few seconds. Okay. Thank you very much. So see you at the next session in a few minutes. I invite all the speakers to raise their hands so that we can promote them as panelists. Bye-bye.
Okay, hello everyone. So it's 5:30. So I think that we can start with this last session of the IAHR Young Professional Congress. This session is titled Water Resources Management 2, and Gaetano Crispino and I, Gonzalo García Len, we have the pleasure to be the hosts of the session. And with us, we have Ángelos Alamanos and Carlos Galbao as the chairs of the session. Carlos Galbao is a professor in water resources engineering at the University of Campina Grande in Brazil, and right now he has been working on hydrologic processes and water management, particularly in semi-arid context. And in the case of Angelos Alamanos, he's a graduate of the civil engineering department of University of Thessaly in Greece and holds a PhD from the same department. And right now, he's in his postdoctoral research at the Water Institute in Waterloo, Canada. So, please, Chairs, if you want to introduce the panelists.
Hello, can you hear me?
Yes.
Yes, perfect.
Okay, welcome everybody. Nice to see so many participants. Although it's the last session, it's always happy to see many people and many young professionals. Carlos, welcome. This is the final session. Happy to have you here again. And we are both members of the technical committee of the IAHR on water resources management. It's Carlos, myself, and a few other members. So if you're interested with a broader theme, feel free to search in the IAHR website or look for us and just drop us a line and email to see about any opportunities to be involved. And Carlos, if you have any comments before we go to the presentations.
Welcome, everybody. It's nice to see so many people here in this online session. Thank you, Angelos.
All right, so we can delve into the presentations. We have the first one by Mohammed Wakar on ChatGPT and water hammer and pressure surges. So we can start, Mohammed. The floor is yours.
Can you maximize it? Thank you. Welcome, everyone. Thank you for joining. This is Dr. Wakar from KFUPM Saudi Arabia, and today I'll be presenting my paper on assessing the understanding of ChatGPT on water hammer and pressure surges, which in general is a topic related to pipeline hydraulics and water resources. So to give you a perspective behind this paper is that I spent about 6 years in the research on water hammer and pressure surges, and then I transitioned from this area to another area of NDT of composites. So as I was starting my new research area, I literally felt I am still nascent and there is a lot to learn. And to begin with, I started with the traditional way of approaching to the literatures and books. So I was reading books and as well as the research papers. But in the meantime, there are some doubts that you cannot really grasp from these literature. So I started using ChatGPT to quickly ask a question, and it usually helped me to understand the concept better. However, soon I realized that there are problems. Sometimes, first of all, there are biasnesses. So as we are communicating with ChatGPT, it keeps bouncing left and right. And the second problem is that there were discrepancies between what is written in the literature and what ChatGPT was producing. So while I checked few of my questions, because I'm still new to this field of composites, it was really not easy for me to evaluate every other response that I was getting from ChatGPT. So this gave me an idea of why not we evaluate its performance on something that I'm very much familiar with, that is water hammer. And that's where I formulated this paper. So basically, to evaluate this, I formulated 3 fundamental questions. They are fundamental, but they are literally simple that we usually cover them in the first 2 or 3 lectures on the course in water hammer pressure surges. So the first one was water hammer, whether it's a linear or nonlinear phenomenon. And ChatGPT somehow was able to understand that most of the phenomena that are happening in general in nature are non-linear. However, we linearize them in order to develop models and hope to faithfully understand the physics of these phenomena. So since I'm taking an exam from ChatGPT, I would evaluate this question as correct. Now, the second question was, under what circumstances the compressibility of water hammer becomes important, because to be honest, many fluid mechanics books themselves mention that water is incompressible. However, it is not true when you have water hammer or pressure surges, and it's all about the time scale and length scale. And thankfully, ChatGPT was able to understand that it's a length scale or time scale problem. However, this answer, I would say, was incomplete, because apparently ChatGPT thinks there are 2 scales and they are independent scales, while it is not really true that the 2 scales are linked to the wave speed, and that the compressibility is somehow sitting in the wave speed, or how we model these water hammer models. So being an examiner this time, I would say this is a half correct answer. And the third question, which I literally think is very simple, about what is the fundamental frequency if we have a reservoir pipeline valve system, which is a very classical system that have been studied in more than 200 to 300 papers in the literature, as well as in the textbooks on this topic. And the correct answer is that the fundamental period is wave speed divided by 4 times the length of the pipe. However, ChatGPT thinks it's C over the wave speed over 2L. So there is a difference in terms of 1/2 factor. Even though I tried to help ChatGPT a little bit by providing some hints, but ChatGPT response did not change a lot. So having this analysis and the responses, the original responses, and my analysis on these questions, I shared the material with the 3 experts in our field, including my PhD supervisor, Mohammed Gidawi from HKUST, and also Professor Ellen Wardy and Aris Seisling, who have made significant contribution in throughout their academic careers. And from their comments, it was really helpful for me to formulate my thoughts as well as my ideas on this paper. Finally, to conclude, I would like to share my learning from ChatGPT with all of you, that yes, it is a great tool to learn new subject, to grasp knowledge, but it is still really not ready to answer many of our critical questions, especially when it comes to research questions, or understanding of our scientific or engineering related topics. So as an examiner, I would assign a grade of 70% to the ChatGPT. And finally, I will conclude my presentation with one of the quote from Professor Alan Wardy. As he was reviewing my analysis, he said that it is only a matter of time before ChatGPT undergoes further training and delivers improved responses. Until that, I think we should keep consulting our experts, our books, textbooks, literature to acquire new knowledge. Thank you so much.
Thank you, Mohammed. That's very interesting. ChatGPT is good in answering factual questions. Maybe it's based on the literature, but it's not good in thinking. It's not. It can hold a dialogue with us. It can be trained.
Yeah.
But as you said, the supervision needs to be there. We need to be critical.
Exactly.
And so we have the second one. We can proceed with. That one takes us to Canada with droughts, remote sensing, and GIS in Ontario.
Hello, do you hear me?
Yes, Amir.
Okay, thank you so much. My name is Amir Nouri, a student of University of Ottawa. I would like to present on behalf of my colleague. On this presentation, the topic is drought susceptibility assessment and mapping through remote sensing and GIS in eastern region of Ontario, Canada. Geographic information system and remote sensing have emerged as crucial tools in examination of various categories of natural disaster. In the current investigation, GIS and remote sensing were applied for the spatial examination of drought conditions within the eastern region of the Ottawa River watershed located in Ontario, Canada. Satellite imagery data of precipitation from GPM satellite for 2019 to 2022 is employed in this study to fill in gaps of observed data. Then the satellite imagery data was extracted using created model builders in the ArcGIS software. Monthly precipitation records spanning from 2000 to 2022 were used for 5 weather stations located across the study area. And severity of drought depends on influence of numerical criteria. 5 geographic criteria affecting drought hazards, including land use, land cover, elevation, slope, proximity to river, and rainfall, are incorporated into ArcGIS for the purpose of hydrological assessment. To improve the accuracy and validity of this hydrological evaluation, the standard precipitation index is used to investigate the drought characteristics. Additionally, data from active hydrometric and weather stations located within the study area is employed, and the IDW interpolation technique was utilized to fill in the gaps of historical and observed data for drought analysis. In the process of creating a drought susceptibility map to normalize the spatial layers, all layers are categorized on a 5-point scale ranging from very low to very high susceptibility. Additionally, using AHP model as a multi-criteria decision-making model, expert opinions were consulted to assign relative weights to each criterion to reflect their importance accuracy. Finally, all of the classified climate, weather, and hydrological criteria were aggregated and overlaid to develop a drought susceptibility map. The result of the study based on the SPI index shows that 1.60% of the study area falls into the extremely dry category, 23.65% are near normal, and 38.4% are extremely wet. Additionally, the final drought susceptibility map reveals that 38.17% of the study area is classified as extremely wet, and only 1.16% as extremely dry. Based on the observed results, the criteria such as rainfall, proximity to river, and land use and cover significantly influence drought severity. This approach underscores the importance of integrating multiple criteria for a comprehensive understanding and effective monitoring of drought conditions, especially in areas like Ottawa River watershed. Thank you so much.
Thank you, Amir. That was interesting. Congrats. It was an integrated study, and seeing that you combined multiple sources like remote sensing, GIS, and meteorological stations, data hydrology, and the SPI index adds robustness to the study because you can examine different angles. And even if we assume that all this data gives us 100% accuracy, which is likely not the case, might be interesting to check what would be the effect of different interpolation techniques besides the IW one, to see how different techniques may affect your findings. So this takes us to the next one. We stay in Canada. We have again from the same author team a GIS and remote sensing study on the Ottawa Basin.
Yeah, good afternoon again, everyone.
Go on.
It's a pleasure to be here with you for a second time today. And this is Amir Nouri, student in University of Ottawa. Unfortunately, Khadijato, my colleague, couldn't join us, so I'm here to present on behalf of my colleague. On this presentation, the topic is GIS and remote sensing application for soil moisture evaluation, case study of Central Ottawa Basin, Ontario, Canada. This study explains how to evaluate the spatial distribution map of soil moisture using GIS-8 and SMAP satellite imagery data in the western region of Ottawa River watershed located in Ontario, Canada. SMAP satellite imagery data from 2019 to 2022 is employed in this study. Then convert the satellite imagery data using created model builder in ArcGIS software. 5 primary spatial criteria, including land use, land cover, elevation, slope, and proximity to river and precipitation, are integrated into ArcGIS for hydrological assessment. To enhance the accuracy of the result, we use the historical and temporal data for climatic parameters, including precipitation, surface runoff, evaporation, temperature, surface wind, aligned with monthly observation reports obtained from operational hydrometric station located within the designated research study. Afterward, the Kriging interpolation method is applied to fill in the gaps in the historical and climate-related soil moisture values. In the process of normalization, soil moisture spatial layers are categorized at 10 points based on Satie scale. In the next step, reclassify each created layer into 5 classes from very low to very high impact based on the 5-point Likert scale. Additionally, to incorporate the importance of each criterion, relative weights are assigned based on expert judgments using AHP model. Finally, all of the classified climate, meteorological, and hydrological criteria were combined to develop an integrated map. The study's results indicate that the maximum surface soil moisture is 22.76 millimeters with a minimum of the 19.32 millimeters, an average of 21.05 millimeters. Criteria like rainfall, land use, and proximity to river significantly influence the soil moisture, and climate parameters, especially precipitation, surface runoff, and evaporation, also play a critical role. The study successfully demonstrates the use of remote sensing and GIS assessing soil moisture in the western Ottawa River watershed. Utilizing SMAP satellite data and GIS-based hydrological assessment provides a valuable understanding of soil moisture variations, highlighting the significance of rainfall, land use, and the river proximity. These findings are crucial for enhancing irrigation strategies and sustainable water resources management. Thank you so much.
Thank you again, Amir. Another integrated assessment. Good to see. It's difficult. It's difficult to have such studies because the devil is in the details. When you have so many different spatial criteria and you try to define the relationship with your factor, like the soil moisture in this case, it's difficult to adequately find these relations, but it's good to see the studies. So we can proceed, and then we have the next paper from the tidal river confluence, analyzing the temporal discharge distributions.
Good evening, everyone. Can you see my screen?
Yes, you're sharing your screen, right?
Right. I'm already sure. I want to confirm before we get start. All participants can see my screen, right?
Yeah, we can see your presentation now.
Yeah. So can I start my presentation? So my name is Niulai. I'm the third year, the final student from the Tokyo Metropolitan University. Today I will present my research topic is analyzing the temporal discharge distribution in a tidal river confluence. So the confluence river is located near the upstream. So that well is have the tidal force coming in effect and causing to the more rivers and converge and flow into the sea. So, well, that place the discharge distribution between the two channels important for the downstream aquaculture and agriculture process. So, but the previous study are mainly focused on the estuarine waterhead areas. So, but our current emphasizing the estuarine area has many previous study carry out mainly numerical modeling and satellite study. So in this our case, I'm focusing on the field observation by using the EDCP, acoustic droplet current profiler, to measure the velocity and discharge measurement. So my target area is located in the Myanmar, the southern part of Myanmar. So the left side of the figure shows the location of study area. So you can see the main channel and branch. So the specific study area is in the junction, the upstream area. So I use the EDCP to collect the velocity and discharge from the low tide to the next low tide. So 30-minute interval. And also I collect the water levels. And for data analytics, I use the salinity index and the normalized area and discharge ratio. It's mentioned in the method session. So in the result, so from the low tide to the left side, the Tanindai River, and the right side is I use the previous result data. Chikuko River is located in the Kyushu region in Japan. So the first figure is represent the water level, and also second is the discharge, and also the final figure is a ratio, the discharge ratio and the area ratio. So from the low tide to the middle low tide period, the discharge of the main channel and branch is around the main channel is 4,000 and branch is orange 500. But from the mid flow tide to the high tide period, main channel is 70 degrees, so to the 300 cubic meter, but the branch is slightly increased around 800. You can see the orange and blue part. In this period, the discharge ratio of the branch, the figure E, is the increase from the 0.1 to the 0.6 of the branch, but the area ratio is almost stable. So, after high tide to the ebb tide period, the discharge ratio returned to increase the 5,000 in the main channel, but the branch decreased the negative discharge value. Well, it's the blue. I make to highlight the blue area, so that period has the negative counter current occur. So in Tanindai River, as during the discharge ratio of the branch to the discharge was changed by the temporal scale. You can see the figure E is the discharge ratio of the branch changed from the low tide to the next low tide, but the area ratio was almost stable. But in Chikuko River, we see the almost area ratio and the discharge ratio was stable, except the low tide condition. So it was caused by the effect of the downstream topography. I focus on the right side of the figure. So I picked the two important periods, the high tide and the ebb tide. I mean the abnormal condition. So in high tide, you can see the branch has a higher discharge than the main channel, because the main channel has the wider more than three times than the branch. So the freshwater, the saltwater intrusion is more upstream, and then it blocks the upstream discharge at the time. But in the branch, at the same time, the discharge suddenly intrusion is a little bit gap. So the main discharge moved to the branch from the main channel. But in the ebb tide, the condition, the reverse condition will occur. So we see the counter currents from the branch. So the period I already highlight in the blue color. So now I will focus the topography. So let me check. The branch in Tanindai, the branch is 43% longer, and then the mean dye is 91% larger. So, but in the Chikuko River, assuming the branch is only 90% longer, and the mean dye is 40% larger. So the topography difference between these two rivers is significant. So for Tanindai, the topography is more than 40. So we conclude that the discharge distribution chain more than 40 significant temporal discharge occur. So thank you very much.
you. I'm not. They can be represented channel if I got you correctly. So thank you.
Sorry, can you? Yeah, thank you, sir.
No, we will have time to the coffee break to discuss it and have more Q&As then. So we can go to the next one from Megaraz on microplastic.
Warm greetings to one another present here. Myself Megha Raj, and I'm here to give a brief idea on a study on efficacy of Pseudium guajava leaf composites in absorbing microplastics from wastewater. So our study basically comprise of studies that basically describes about the efficiency of Pseudium guajava leaves in removing the microplastics that are basically present in wastewater, which is emerging like an emerging contaminant. Now, we basically conducted our experiments basically on two type of guava leaves. One is a non-magnetic guava leaves and the other one was the magnetized guava leaves. Non-magnetized guava leaves were prepared using thermal method, while the magnetized guava leaves were prepared using co-precipitation method. And we prepared different concentration of Pseudium guajava leaf composites varying from 0.1 gram per liter to 0.8 gram per liter. And to each of the conical flask, we also added same concentration of polystyrene, like 0.1 gram per liter, which is actually a kind of microplastic. And in rotary shaker, the mixture was actually shaken for about 3 minutes under 250 RPM, followed by mild shaking at 60 to 70 RPM for 2 minutes. Now, after that, we actually provided some 120 minutes settling time, and we were able to observe the formation of flocks of polystyrene and microplastics. So this basically describes that Pseudium guajava leaves are efficient in removing the microplastics that are present in wastewater. Now, to analyze how this removal has taken place and what phenomenon has taken place, we initially conducted FTIR result, and the FTIR of Pseudium guajava particles showed a strong peak at 3518 centimeter inverse, indicating the alcoholic stretching or the intermolecular bonding. And FTIR of settled flocks showed strong peak at 3414 centimeter inverse. So this shift in peak itself indicates some kind of strong interaction that is present between the guava leaf particles and Pseudium and polystyrene. Maybe something like some hydrogen bonding or some electrostatic interaction. So to analyze further what kind of interaction has taken place, we conducted some analysis, and we observed that the non-magnetized guava leaf particles possessed some porous structure, the polystyrene possessed some filamented structure, and coagulated flocks possessed smooth surface. So this basically inferred that the filamented structured polystyrene, that is a microplastic, got adsorbed on the surface of non-magnetized guava leaf particles that basically resulted in the formation of this smooth surface flocks. Now, after this adsorption and after the formation of this smooth surface flocks, the flocks settled, thereby achieving removal of this microplastics from wastewater. Now, from our experiments, we have observed a percentage reduction of microplastics as some 98.5%, and we could utilize this natural property of Pseudium guajava leaves in bringing out innovative solutions for wastewater treatment and environmental management. Thank you.
Thank you, Magar. Always interesting to see solutions contributing to the microplastics removals. We can go to the next one, the isotopic characterization of groundwater from Duma and are they here or?
He is not present now in the room. We can skip and wait for his presence.
Thank you, guys. And we can skip it, and that takes us to the next one, to the prediction of energy dissipation from Becker. Oh, yeah.
Hello, everyone.
Hope I'm audible to you.
Yes, we can hear you.
Okay, thank you. So a very good afternoon to all of you. My name is Ritushnata Mishra. Currently, I'm doing my PhD in Indian Institute of Technology in the Department of Civil Engineering. And my presentation is on prediction of energy dissipation of nappy flow by using machine learning approach. So basically, flow over stepped spillway is categorized into three different flow regime, named as nappy flow regime, transition flow regime, and schemic flow regime. As the flow regime is different, then definitely the energy dissipation mechanism will be different for different flow. So during modeling, the modeling should be done for particular flow regime in order to maintain the physics of flow. My work is basically on nappy flow regime. So therefore, different experimental data sets are collected from different resources, like from papers of Janssen 2002 and Felder 2019 and all. And overall, around 88 number of data sets are collected. And to go for the combination of input parameter, dimensional analysis are conducted to find out the energy dissipation, which is a function of critical discharge, height of the spillway, width of the channel, and the channel slope. So after getting this input parameter, we can go for splitting of data sets for training and testing purposes. Around 72% of data are collected for training purposes, and rest of the data are taken for testing. And then we're going for the modeling. As here, SPM model is used, and in SPM model, three different kernel methods are used, likely SBM RBF kernel, SBM poly kernel, and SBM PUK kernel method. And in the agreement diagram, in figure 1, you can see the predicted value and the observed values of SBM RBF model and SBM poly model. And the 1C is SBM PUK model. Here you can see the SBM PUK model is showing pretty good result as compared to other kernel method. And it's showing a correlation coefficient of 0.99 during training, and for the testing, it is also showing good result of 0.97. So overall, it is showing good result as compared to other kernel method. Here also, now one of the analytical expression which is given by Rajaratnam 1994 in the equation 2, which is compared in figure 1D. Here also is SBM-PUK model is showing good result as compared to the analytical approach. So in the conclusion, you can say a comprehensive study is conducted, gathering experimental data sets from different resources, and SBM method is used by three different kernel, and out of all, SBM-PUK kernel method is showing pretty good result as compared to the other kernel, as well as the expression given in the literature research Rajaratnam 1994. So overall, we can say during prediction of energy dissipation, basically for the nappy flow regime, machine learning approach is doing well, specifically in SBM PUK model. Thank you. That's all my presentation.
Thank you, Mr. It's very nice. It's good to see that you consider multiple parameters, actually, all the spillway dimensions.
Thank you.
So we can go to the next one. Looking at the closed oxygen reservoirs. From Kairi, Duka, Atikohan, or Yokoyama. Are they here?
Hello.
Hello.
Hello, everyone. Sorry for my late.
No, no problem. We will share your presentation so you can start your talk. Okay, here it is. Go on, the
Yes,
floor
could you please
is yours.
Hello, everyone. My name is Ghazal Khairi. I'm from Tokyo Metropolitan University. The research topic is relationship between turnover and bottom dissolved oxygen in a deep reservoir from 1993 to 1996. The turnover process is a natural phenomenon that causes redistribution of dissolved oxygen in a water column. Since there has been few research on turnover, this research explores the variation of DO associated with thermal stratification and turnover in a deep monomictic reservoir. The study site is Oguchi Reservoir located in Japan. The depth is around 105 meters and the reservoir area is 4.25 square kilometer. Data was collected by Tokyo Metropolitan Government and it's near the dam wall at depths 0, 2 meter, 5 meter, every 10 meters until 2 meters above the bottom. And the data that we used were water temperature and dissolved oxygen. The data is weekly data. So we calculate the thermal stratification indices, TG and SSI, thermal gradient. As you can see in figure 2, the schematic show for thermal gradient, we calculate temperature at the surface minus temperature at the bottom divided by depth. And for SSI, SSI is the amount of energy that is needed to be done by wind to overcome the thermal stratification. For SSI, we calculate the density and area at each depth. Moving to the result, figure 3A show air temperature that is collected, that is obtained from Amedas data. And the next one show water temperature contour map. C and D show TG and SSI linear graphs. And then last one, figure 3E show contour map of DO. If you, for figure 3A, when temperature increase from April to August, water temperature also increase and TG and SSI increase and reach the maximum value in August. TG maximum value is around 0.2 centigrade per meter and SSI is around 8,000 joule per square meter. The bottom DO started to decrease from May and result in hypoxia. Hypoxia means DO less than 3 milligram per liter. The dark red, as you can see, the dark red from June onward. By decreasing air temperature from September, TG and SSI also decrease and reach the minimum value in the winter. The winter show in the highlighted part. Show in the highlighted part, and when minimum, we have minimum TG and SSI, turnover occur, and as you can see, turnover occurred in the winter. So we check the average of the OTG and SSI for 2 periods, before and after turnover during winter. A strong negative correlation was found between DO with TG and SSI, and the R square show bottom DO with TG, the relationship R square show 90%, and bottom DO with SSI show 97%. As a conclusion, hypoxia disappears while isothermal condition forms, which show the occurrence of turnover. And the next one is TG and SSI are useful for determining turnover occurrence during winter. Moreover, a strong negative correlation was found between DO and thermal stratification indices. That's all.
Thank you very much, Ghazala. It's interesting to see what's happening at the bottoms of the reservoirs.
Thank you so much.
With this, we can go to the final one. The contribution of natural anthropogenic factors and how groundwater varies in northwestern United.
Good evening, everyone. I'm audible, right?
Yes, go on.
Yes, thank you. So good evening. My name is Varun Desai. I am presenting our work on behalf of my colleagues from the Indian Institute of Technology, Jodhpur. So our project was to carry out an analysis of the contribution of anthropogenic factors on groundwater variation in a selected area. The area of interest we selected was northwestern Rajasthan. So what we did in this study was to identify all the major canals which are present in the study area. These include the Indira Gandhi Canal, Bhakra Nangal Canal, and Gang Canal. And based on the amount of water flowing through these canals, the reaches of these canals, we can find out the command area of these canals, basically the region where irrigation is carried out using these canals. So in the map, we can see in the first figure, we can see that the shaded area is the command area of the canal. So this is represented by IRCW, where irrigation is carried out using canal water. And the rest of the map is IRGW, where irrigation was carried out using groundwater. Now the data sets we made use of was groundwater data and precipitation data. And we made use of VIC SIMGM model from Ashoka et al. And this model takes in precipitation data and other ground parameters. And based on these, it gives a prediction of simulated groundwater data under an ideal condition. So that basically neglects all anthropogenic factors and gives us a prediction of what groundwater data should be given the amount of precipitation. So from the model, we have an ideal groundwater data, excluding all human factors. And then from the observed groundwater data, we know that in the presence of human activities, this is the groundwater relation we have observed. So based on both these data sets, we can calculate the exact amount of influence that groundwater has had, that anthropogenic activities have had on groundwater. So we observed that for the command area, that is IRCW, anthropogenic factor contribution was extremely high, 74%, because canals are basically man-made, and that is why we had a high impact there. For the same reason, we also calculated correlation factors, and because canals are high, the correlation between precipitation and groundwater levels for command area was observed to be significantly lesser than a non-command area. Because of the presence of canals, even if there is some variation in precipitation amounts, because of the presence of canals, there is sufficient water available for irrigation. And for the same reason, there is enough water for groundwater infiltration at the same time. So that is why in command areas, we have observed a low correlation. In non-command areas, we have observed a high correlation. So with that, I can conclude the results we obtained. Thank you very much.
That's a lot of data. Was it annually or monthly, all this data?
The precipitation data was annual and the groundwater data was quarter annual.
Okay, that's nice. Okay, congrats. So I was wondering if the one author that we skipped, if they are here from the isotopic characterization of groundwater, I think. Probably not.
Yes, Raviande, exactly. He's asking, he's raising the hand.
Okay, is he here? He can
He's
present.
here, yes.
All right, all right.
Ravi, you have to accept the invitation to be panelist, okay? Exactly. Ravi Andes has the role
Yeah, I
of
see.
panelist right now, so.
Okay, Ravi, are you with us? You're muted.
Sorry, sir. Is it visible?
Yes, yes. We're with us now. I can hear you.
Okay. Sorry, I could not join in time because due to my poor health condition. Yeah, this is the isotopic. So I selected my area in the
We cannot hear you, Ravi. We're losing you. You're coming and going.
Okay, sir. Is it audible?
Yes, yes. Now, yes, but we lost you before. We could not hear you.
Yes, yes, yes. Yeah, this is the area of the Kerala, southern part of the India related to the isotopic characterization and groundwater recharge mechanism in Kozhikode district of the Kerala. It is completely southern part. The eastern Ghats, the strip of the Kerala surrounded by eastern part of the um eastern Ghats and uh, uh, so the area was selected based on the different diseases and seasonal diseases and waterborne diseases. So this area is what there are water fluctuations and even based on the seasonal diseases. And when I collected my samples, the pre-monsoon and post-monsoon samples, which I collected in the area, based on the stable isotopic characterization, the water in the field of the Kozhikode area. The highest elevation is like 282 meters and the lowest elevation is 94 meters from the mean sea level. So I followed that collection of my data, the primary data collection, field investigations, identification and description of the sample sites, and groundwater level measurements, the sampling and analytical techniques, even groundwater sampling for hydrochemical analysis, groundwater sample for stable isotope analysis. So I observed the relationship between the oxygen and deuterium of the groundwater and rainwater in the urban and peri-urban area of the aquifer system. So the urban and peri-urban area is like when the flooding takes place, it is completely changing due to the fresh precipitation and where the coastal area is water is merging with the fresh water and mixed with the fresh water and fresh and saline water. So the completely when we observed that through my analysis, the values are completely changing and it is showing the very high, the based on the seasonal variation. So it is in the because the area is completely under the tropical monsoon condition of the geographical condition. So the area also like diseases mainly waterborne diseases also spreading easily in that area. So through my research, I suggested to groundwater board and local water bodies which are working under the local groundwater board or central groundwater board to take the precautions to provide the fresh water. Even there are like the saline water, like the urban flooding. When the urban floodings are happening, the local people are suffering more. So the more contamination, the water pollution also taking place more in that Kozhikode district. So I through my conclusion, I suggested the health department and even central groundwater board and local groundwater board of the Kerala. So even fluctuations low, I observed like even water fluctuations by seasonal variation. I I took the help of the even central groundwater board to the measuring the observations of the water levels and precipitation and the local based on the local uh, uh, groundwater and weathering conditions. So uh, uh, so aquifer, so in the aquifer condition low, so we observed like distribution of the oxygen and hydrogen isotopes in the uh, groundwater subsurface through southern India, from the Kerala and the coastal belt of the Kozhikode district. So thank you, sir. Thank you for giving this opportunity.
Thank you, Ravi. And thank you for being here with us. I think it's in India, it should be pretty late now, right?
Yes, sir. Yes, sir. It is 10:50 p.m.
Yeah, thank you, thank you. So
Yeah,
we
thank you, sir. Thank you.
have finished with the presentations,
Yeah.
and we are ahead of time already. We have also almost half an hour for questions and discussion. So if you like, those who can just turn on your cameras, it would be easier and to stimulate more interaction if you have any questions.
Yeah, sir. Due to some the cold weather, so I inculcate with this weather. So I'm headache, some weather, some health issues are happened. So unable to explain proper way.
Yeah, no problem. We're
Thank
able
you,
to
sir.
get most of it.
Mm.
I see some questions in the Q&A chat. There is a question from Ubash to Nuri. You used different interpolation methods in your two studies. How did you choose these methods? What about other methods?
Yeah.
Okay, Nuri is
You
here.
hear me?
Yes, yes.
Actually, the choice between these two models often depends on the specific requirements of the GIS project, including data availability, special patterns of the variables, and I don't know, the level of complexity the user in prepared to handle. IDW is simpler and faster, but less sophisticated. It relies on the inverse of the distance for interpolation, and kriging, on the other hand, is a more advanced and accurate method, taking into account spatial autocorrelation and providing uncertainty estimations. You know, dealing uncertainty is one of the most important aspects, especially in those works we face with several criteria. But it's require more complex statistical understanding and computational. But it's referred to the project requirements. That's it.
Most of the times we're forced due to the lack of data and their nature to choose our methods. If you try to get a paper out of this, it would need to pay very much attention on how much to justify these things. And also the way that the experts in your papers assign the weight, the expert judgment. It's another issue that many people ask about this. How did it happen? What was the scales used, or what's the relation with the literature studies that you draw upon? Another question from Gubash again is from to the Ritusnata Mishra paper. What is the application of your study? Which paper was that? The one with the machine learning paper, I think. Yeah. Mishra, are you here? Yeah, I see here.
Yes, he's here.
Hi. Yes, I'm here.
Yeah.
So my question is like, what is the application of the study? Okay. So by this approach, we can get more details about what are the input parameter, more specifically for the contributing predictors because my research is particularly on apophorism. If we'll go for the flow over stepped spillway, all different florisms are there, like scheming florism is there and transition florism is there. For each particular florism, there will be different input parameter. And if we'll go a thorough study of this parameter, we can predict the energy dissipation more accurately. So for that, it'll be helpful. Hopefully, I can able to answer this question.
Yeah, that's helpful.
Thank you.
Did you try different kernel methods when you?
Yes, I have tried SBM 3 kernel method. One is SBM BUK kernel method, SBM poly kernel method, and one is SBM RBF kernel method. 3 kernel methods I have used. Yeah, thank you.
And in different, I had the question myself when I were presenting this graph with simulated results.
Yes.
Your model was good in any dimensions or any geometries, or is there a particular geometry of spillways that it was more effective than the other?
Sorry, I didn't get.
Yeah, so you used machine learning to predict
Yes.
different parameters from a spillway. So
Yes.
considering the
These are
different
some input
geometries.
parameters. Yes.
Yes. So
Yes.
considering the different geometries, was there some geometries of the spillways that your models are better, are performing better, are more accurate? Other?
I have taken different input parameter in terms of two things. Like one is in terms of geometric parameter, I have taken the height of the step, each particular step, and the height of the spillway, the width of the channel, as well as slope. So by taking all this parameter, it is showing better results. Because all these things are depend on the geometry of the steps, how we can design the spillway so that it can dissipate the energy in a more efficient way. So it depends on geometry and the flow rate conditions. That's it.
Any geometry?
Yes.
That's good.
Thank you.
And if you, we always need learning has the tendency of better. So the back of our heads always. Okay. Next, we have a question for us this side.
Hello. I would like to answer it. The main anthropogenic factors we considered was firstly it was irrigation, and it was basically the presence of human settlements in and around canals, because northwestern Rajasthan is mostly a desert-like region, barring a few cities, the major ones. So it's mostly a desert inhabited region. So there are very less people living there, and mostly the settlements are around canals. So the human presence there, the water used by them for domestic purposes, but the main factor again, as I said, was irrigation.
Groundwater.
I'm sorry, I could not hear you. Will you repeat, please?
Yeah, so it's the one that you said earlier that you used annual precipitation data and quarter annual for the groundwater.
Yes, sir.
Right. But you convert them in the same units when you did your modeling.
Yes, we converted them to the same units. The data, precipitation data we obtained was actually daily, and it was for a lot of stations. So we had to isolate those and then convert them to the same units as groundwater data.
Angelos, we cannot listen. We cannot hear you.
Angelos, we can't hear you.
Text him or
Yes.
say from the chat if he's here. He's here. I think he posted a question as well.
Angelos,
It's okay.
maybe. Yeah, please, Carlos, continue.
No, I started to hear you again, Angelos. So please proceed.
You can hear me now?
Yes.
Exactly.
Okay. Yeah, I was trying to read the question from Gubas to Ravi, and I think Ravi is here. So, Ravi, can you hear us? Can you hear me?
Yes.
We can hear you,
Okay.
but Ravi.
But we struggle to hear Ravi. Ravi, you can just type a question. If you cannot connect or we cannot hear you for some reason, you can just type your answer.
Not audible. Not audible.
Can you hear us? No, anyways, Ravi, if you see the questions, you can. There was a question about the recharge mechanisms that you used. So you can type the answer, unless you cannot be heard here. And with that, we can go to the next question. I see it in the chat. However, it's a question from Ravi to Mishra. So what are the machine learning tools that you used? Mishra?
Hi, yes.
Hi.
So, what is the question?
There is a question for you in the chat saying, what are the machine learning tools that you have used?
So I have used SPM model, and in which SPM kernel method I have used, particularly 3 kernel methods I have used. Like first one is SPM RVF kernel method, SPM polykernel method, and SPM PUK kernel method. So there are so many methods are there in machine learning. Like for different data sets, you can just try which data sets is showing good result and which model. So this is important for choosing the best fit model. Thank you.
Yeah, of course. So that's good. Are there any other comments or questions? Anybody? No? Carlos, do you want to speak about something? Any comments on the interesting paper you saw?
Very happy to see the variety of papers and approaches, and these sessions of more process-oriented presentations that are also very interesting. And I would have a questions to the first paper, Mr. Wakar. In your conclusion, you say we need to validate information obtained from other large language models, such as ChatGPT. Can you wonder how to do this? How can you approach these kind of models? And as you know, people are already coding using large language models, and so how do you see this challenge?
Okay, so can you hear me?
Yes, yes.
Okay, so basically in this paper, since I am evaluating ChatGPT on the research-oriented question, or that's a fundamental question related to engineering field. Of course, ChatGPT is being used for coding to generate codes as well as to make some prediction models as well. But my concern was, as young professionals, we tend to use ChatGPT to pretty much question every other doubt that we have, and we may end up getting responses that are not really valid. So my message through this paper to all the audience here and in future, whoever will read this paper, is that if you're asking a scientific question that you don't know, and you get a response, I think it's better to validate through your supervisor or someone from the field, someone who's expert. That's basically what I'm trying.
Thank you. I think we have this challenge to systematically validate such models as a guidance to, particularly to young professionals. It's an open challenge.
Thank you.
Studies increasingly try to validate the outcome that they become, but they use very structured ways. They have satisfying answer, and they use gradient scales to say that up to which point ChatGPT can reach to this satisfactory answer even after training model. And it's always good to have that the data that it's using, I don't know when they're not up to date always. They are until last year or so. So yeah, it's good for some things, but yeah, in general, we need to be very careful and be closely supervising what we get out of it. So any other comments or questions? It was very good to see that we have many different studies, and it was a geographical spread. We saw cases from our experimental study in Canada, and that was interesting and maintained the interest, and we were very happy to see that. And most of them were very applied things and applied methods, so that was also good. And as you saw, most questions were targeted on the methods and what you used, how. So one takeaway message from this exercise is to always focus on the transparency of your methods and the ways that you are presenting them. And always have in mind the practical implication. Okay, I found this data. What's next? How can I use them? How can I contribute to a better water management problem? So that will be good for all papers. Very interesting papers. So well done and congratulations. So if there are no other comments, we can close the session, I think.
Okay, perfect. And maybe, Angelos, we can take a photo together if if the speakers want to turn on the cameras, I can take a screenshot of the session. Okay. 1 minute. Perfect. Thank you very much.
Thank you. Thank you.
Right. Okay, so thank you, Angelos, and thank you, Carlos. With this session, this was the last session of the Congress, but the Congress is not finished. So I would like to give the floor to Michael Nons.
Yeah, thank you very much. Yeah, it's not finished. I just would like to wrap up a bit and show you some final slides. So just give me 1 second. First of all, thank you to all the speakers and all the chairs also for this very last session. So, well, yeah, this was the 4th IAHR Young Professional Congress. It was done in these last 3 days. And here are just a few numbers. As you might know, we received more than 130 abstracts, which translates in more than 300 authors. So all these abstracts were multi-authored, and those abstracts cover all the teams that IAHR is actually running. And these abstracts were reviewed by an international scientific committees of more than 90 members. Because, well, to guarantee a high quality of all the presentation that you saw in these last 3 days. I would like to thank all the organizing committee members. We were 11 people and we worked all together for the last month. I would like to thank all the chairs, not only the ones that lasted till the very end, but all of the others as well. And also the supporters, which are 5 associations and the main sponsor, Bechtel. So in terms of some other numbers, well, we have more than 9,900 registered participants, which translate in like more than 150 online contemporary attendees. Depending on the session, we have more or less attendance. We have a keynote lecture and 12 technical sessions which were chaired by more than 20 experts. And as you can see here, we have a kind of relatively even distribution between genders, with some predominance in terms of male attendings, and also, well, like 1/3 of the registered participants are IAHR members. So I would like to invite all the others to become members of IAHR. You saw this Congress is just one of the activities that we are running. But I would like to invite all of you to consult the website and figure out if the association could be of your interest, and to eventually register and take part to the rest of the activities of IAHR. Last but not least, the map of the abstracts on the top right, the red map, and you can see that we receive our abstracts from basically all over the world with large participation of the Americas and India and Asia. And in the green map, you can see the distribution of the registration. And as you can see here, we have attendees from all over the world. We were able to cover more or less all the countries. So saying that, I would like to thank again all of the people that attended the Congress. And I would like to I would like to invite you to send us any comment. In the future, we will also share a survey so we can have more feedback, more information on how to improve this Congress. And well, see you next year. With that, I think we can close here the Congress. Thank you to all the chairs. Thank you, Angelos. Thank you, Carlos, for having run the last sessions. And thanks, Gonzalo, for being the host of the last session. Thank you very much. See you.